Dobry. Tak, dobrze. Dzień dobry. Chyba słychać, żyje mikrofon czy nie żyje? Żyje, tak działa, dobrze. Dzień dobry, witam Państwa. Good morning. I have to speak in two languages because we have to be polite. Welcome to the conference summarizing our long-time project, the Regional Initiative for Excellence, Regionalna Inicjatywa Doskonałości, which it was quite a big project engaging quite a few scholars from the Krakow University of Economics and from other schools. What have I to say? It's good that in Polish we say, wszystko dobre, co się dobrze kończy. And in this case, of course, we may say that everything is good, what is ending up successfully. And undoubtedly, at least looking at the work of our group, which was pretty hard, sometimes very stressing. I think that Professor Sołtysi can confirm it, that not only me, but I was convinced that everything will be and that will finish successfully. The topic of this conference, of this meeting, is complexity and Industry 4.0. We'll have a series of presentations till 4 o'clock in Polish, but we'll try to translate it. What were the main achievements? Several papers or books and papers devoted to this very interesting topic, and especially in relations to the Industry 4.0, which is becoming very, very, very important area of practice, and of course it puts before a lot of demands for theory, and so that was quite important that the team, part of us are present here, was able to deliver an interesting research, which we may say that sometimes it has achieved the word level, not just another word, just another paper or chapter, but something that could be insightful also for the others. So actually, if I try to summarize, I've mentioned the complexity in the Industry 4.0, then the presentation that we'll have about complexity and Agile, together with, I'll present the team who has prepared the work. Then also there are other works that our other authors will present here. What is also important, and in this project, we're able to develop a strong international cooperation. Soon we'll have a guest, our colleague from Slovakia, then other professors, and additionally, during the work on this project, we've extended the contacts with many, many scholars all over the world, and I think that is also an important contribution of this project on our part. So I think that I'm not going to extend it too much, but just and we'll wait for we'll have a 5 minutes break waiting for the first presenter, unless you had any questions. I'm very pleased that such a small team, but I think that it's important that then we can learn about this. So I think that thank you very much once again. Sorry, I switched to English. We assume in Poland that everybody speaks English. That is not true in other countries like Spain, Italy. But we wanted to be polite to our guests. When we have the presentation, so part of our presentation is in English. So in this case, we'll try to be hospitable to our foreign guests. Okay, so thank you very much. Dziękuję Państwu za uwagę i w takim razie poczekajmy. Czy tutaj pytam się zapraszającego, nasz następcy mówca dotarł, tak? Proszę, już jest, bo będzie online. Przepraszam bardzo, bo ja myślałem, że jest obecny tutaj fizycznie. Okej. W takim razie prosimy bardzo, pan profesor Martin Straka. Yes, okay, please, you are welcome. Witamy pana. Oj, zapomniałem, jak jest po słowacku, bo staram się być uprzejmy i prosimy, to w zasadzie może bez przerwy pan w ten sposób będzie miał więcej czasu. O godzinie 9:45, nie wiem, czy muszę tłumaczyć, my się rozumiemy, 9:45. Mamy następny zespół. Ja proponuję, że to jest około, pan ma ponad pół godziny, więc tak, ile pan uważa potem, że byłby jeszcze czas ewentualnie na dyskusję i pytania. Prosimy bardzo, panie profesorze.
Szanowne Państwo, bardzo miło mi jest łączyć się na Waszą konferencję. Ja mam przygotowaną prezentację po angielsku, dufam, że to nie będzie jakiś problem, ale na uwod parę słów i po polsku, bo ja dużo lat som uczył na Uniwersytecie w Zielonej Górze przedmioty na logistyku. Dlatego i po polsku nie mam problemów, będzie kombinować w ramach prezentacji. Co się tyka mojej prezentacji, ja będę rozmawiać krótko i o moim pracowisku, o moim instytucie, krótko o mnie, projektach, którymi my się zajmujemy i całe to będzie orientowano na reverse logistics and waste processing. Again, greetings from Slovakia. Ladies and gentlemen, dear colleagues, friends. For the given time, I prepared a short presentation on the topic, a contribution to the issue of reverse logistics with a focus on waste separation. I hope that you can see my presentation in this online area. I hope that hardware is working fine. During my presentation, I will briefly focus on information about me, my workplace, solved projects, with an orientation to a specific case study in the field of reverse logistics and waste processing. As you can see, my name is Martin Straka, and I work as a full professor at the Institute of Logistics and Transport, Faculty of Mining, Process Control and Geotechnologies, Technical University of Košice in Slovakia. I have been working at the Institute since 1998. I specialize in the field of logistics, mainly in distribution logistics, production logistics, computer simulation, information logistics, but I also solve tasks from other areas of logistics. Since 2019, I have been working as Vice Dean for Science Research Activities and Education in the third level of university education. The Institute of Logistics and Transport gradually developed into its present form from the Department of Mining, Mechanization and Automation. The Department of Mining, Mechanization and Automation was founded in 1952, which over the years was transformed in 1972 into the Department of Process Management, in 1999 into the Department of Logistics and Production Systems, and into the Department of Logistics was transformed in 1915. The institute is made up of 5 specialist workplaces, as you can see on this slide, and particularly it is Department of Industry Logistics, Department of Transport Logistics, Testing and Verification Workplace of Rubber Products, Slovak Center of Logistics, and Test Workplace of Steel Ropes. The Institute provides logistics studies at all 3 levels of education, bachelor, engineer, and doctor, in the study programs, transport logistics, commercial logistics, and industrial logistics. The subjects taught at our workplace are based on the structure of the micrologistics model of company, which is formed by the flow of materials, horizontal axis, the flow of information, regulations and decisions, vertical axis, and the knowledge base, z-axis. The core consists of a group of subjects such as supply logistics, production logistics, distribution logistics, commercial logistics, levels logistics, computer simulation, transport, logistics of service processes, and information logistics. The faculty is a member of the AET Raw Materials Group, which solves international projects in a consortium of European companies. A number of educational and research projects for various domestic and foreign research agencies, as well as projects for practice, are handled at the workplace on the Institute and by me. One of the issues that we solve within the workplace is also reverse logistics and waste processing. Now will be several questions oriented for the reverse logistics. The first is, what do we mean by reverse logistics? There are a number of definitions about reverse logistics. Out of all of them, I chose at least these two from the authors, Murphy and Poist and Lambert and Stock. I think that you know these authors. And according to Murphy, Poist, reverse logistics is the movement of goods from a consumer towards a producer in a channel of distribution. According to Lambert and Stock, reverse logistics is walking in the opposite direction on a one-way street because the vast majority of goods flows in one direction only. On this slide, you can see the logistic propeller, which represents the constantly repeating logistics activities, and one of them is reverse logistic 2. This is never-ending repeating activities oriented for or necessary for all companies which realize some business or production. The next question is, what is the difference between traditional forward logistics flow and reverse logistics flow? As you can see on this slide, we can say that in the reverse logistics flow, shippers generally do not initiate reverse logistics activity as a result of planning and decision-making on the part of the firm, as is the case with the traditional forward logistic flow, but in response to actions by customer or downstream channel members. This is a small difference. The next question is, what is the goal of reverse logistics? The goal of reverse logistics is claim, repair, reuse, recycling, or disposal in accordance with applicable regulations and guidelines in an ecologically desirable manner. Exist two ways how we can understand reverse logistics or reverse logistics: American way and European. European way is oriented for waste, recycling, reuse, repair, and American way is oriented mainly for back the not use goods or some change or some reuse or some remake. The next question, what about the collected goods? The collected goods can be divided into categories according to the method of processing into direct reuse, correction, recycling, reworking, upgrade, and cannibalization. Direct reuse it means that we can direct use the goods or not waste, but these goods as without previous repairs. Just for example, clean the packaging as, for example, bottles for the beers. The collected goods correction, it means that broken products are repaired to a functional state. The collected goods recycling, the products or its part is disassembled into its basic materials, which are reused as raw materials after processing. The collected goods reworking, the product is disassembled into parts which are checked, while damaged and worn arms are replaced with new ones. The collected goods upgrade, similar as repair, but the resulting product is of a higher quality and value. And the collected goods cannibalization, one or more parts of the product are used to repair another product. On this slide, we can see case studies which were solved for the incineration factory, and particularly it is project utilization of computer simulation for waste separation design as a logistic system, modeling the process for incineration of municipal waste, and project the simulation model of the material flow of municipal waste recovery. In the following parts of the presentation, we will focus on practical solved tasks related to waste processing. The main goal in the frame of the research system for the incinerator factory is monitoring the amount of secondary produced raw material and the systematic demands on production for the particular region in Slovakia. Within the institute, we have a long history of using computer simulation to solve specific tasks. Many tasks cannot be solved without computer simulation. For example, if the system is fictitious, only in prototype stage, or in a real practice, it would take years to verify a number of variants of possible producers, or for something other. At our institute, we have been using the extensive simulation system for many years. The basis of effective creation of simulation models is sufficient quality information and data. From the obtained information and after thorough analysis, we will compile a formalized scheme of the system under investigation. On this slide, we can see the formalized scheme, which represents a complex system with its elements and relations. The elements of the system form individual parts and operation with the waste. Among the individual operations, there are relations which are created by elements of transport, management of waste flow, and rising separated materials such as plastic, biological waste, paper, multi-layer material, glass, textile, metals, wood, gum, dangerous waste, electromaterial, inorganic waste, and no recycling waste. The created formalized scheme shows that the company processes 83,000 tons of waste annually or per year. the formalized scheme of the system under investigation of the same company, but this formalized scheme and the solution of this project sorry, is oriented for the complete separation of waste. The next step for the solution of these two projects is prepare the block diagram scheme, and the block diagram represents an inactive model of the investigated system assembled according to specific blocks of the simulation system extensive. The block diagram is important for the preparation of data and information that are important for setting up the individual blocks of the simulation model. This is the same block scheme of the complete separation waste system. The simulation model of the incinerator consists of blocks that represent individual parts of the operation within the chemical complex in Kokshow-Baksha. Each block of the simulation model has its meaning and justification. Not all operations can be modeled with one relevant block, but several blocks must be used in a sequence that corresponds to the real activity of the company. You can see that we solve each part of the incinerator company as a complex or complete separation of waste system. On this slide, we can see simulation model prepared in a particular simulation system extensive, which is created from the particular blocks. And on the next slide, I prepared short video. I try play it. Yes, I hope that you can see it. One ball on this model represents 1 ton of the waste. And you can see that this ball changed the color on the position waste combustion. It means that this waste was burning, and from, for example, for the 1 ton of waste after burning is only around 200 kilograms dust. It means that for the simulation creator change the color of the ball, it means that I know that the waste is after combustion or incineration. This is model for the system, which is in reality today too. It means that incineration factory realize mainly waste combustion, and the secondary is the separation of the waste. System extensive, sorry, after finishing shows graphs where we can see results after simulation. When you click on the rabbit, system is working quickly, and when you click on the button turtle, system is running slowly. On this slide, we can see the second solution, the same system in the incineration factory complex in Kokshow-Baksha. And it is a complete separation of waste system. This system is prepared in an extensive system and is built from the particular blocks. And on the next slide, I have prepared again short video from or how is running this system. And again, one ball represents 1 ton of waste, of municipal waste. But in this model, we separate or totally separate all waste which is coming to the incinerator factory. We have data, statistical data from the incinerator factory, how percentage is glass, how is biological waste, how percentage is paper, iron, non-iron materials, dust, etc. Once more, again, if we click on the button rabbit, system will be working quickly, and when we click on the button turtle, system will be running slowly. What is interesting on the extend sim simulation system, it is that this system creation of the model, simulation models in this system, we can realize discrete simulation and continuous simulation together, which is it is not possible in all simulation systems which are on the market. These systems is products of the American company Imagine That, which produced this system more than 20 years. If I have good information, this system is used in many universities, in the NASA, and this system has several first position on the market. This is the first system with drag and drop creation of simulation models. Okay, on this slide I have prepared results of the simulation of incineration. We can see that extensive prepare graphs, and by examining various settings of the system and from the outputs of the simulation, it can be concluded that on the overall reduction of the production of emissions and slag during and after incineration, influence the consistent separation of the waste on the entry to the incineration factory. And on this slide, I have prepared graphic results after simulation, solution complete separation. And the simulation results show that the suggested complex system of waste recycling in the frame of the search region can process the yearly production of communal waste. We compare these results from the solution of both projects, and after a simulation, we can say that, or is possible to say that the complete separation of municipal waste is economically better than totally or full incineration. As economical stage, then for the ecology too. And I think that this is the last slide of my presentation, and thank you for your attention. Dziękuję za uwagę i ja dúfam, że stále sme online a vidím, že jest to w porządku.
Okay, thank you, Professor Svaka, for a truly interesting and almost even fascinating presentation. Now I have a question. So let me switch to English now that's easier. Are there any questions from the audience?
Okay.
Then you can pick up the questions. Okay, please. Any questions? No, I have a few, but I don't want to impose myself too much on this meeting. So, no questions, nie ma pytań? I have two, basically.
Trudniej polski może być pytanie.
Dobrze, może być po polsku. Tylko my mamy tutaj gościa, wie pan, który nie rozumie po polsku. Mamy uczestnika konferencji, który to wie pan, możemy po polsku. No, także to, jeśli państwo pozwolicie, to we'll switch to English because it's easier. Okay. First of all, congratulations. Truly, this is, I know a little bit about technology, so this is really fascinating and impressive, but, and it's not a critical point, but on the contrary, it's something, somehow a support of your idea. What about the value of the reverse logistics? Because you've presented a perfect engineering approach. Now, this is the problem, that it may turn out that it's an important theoretical problem, for instance, even for habilitation. And a series of papers in top-level journals. What is the value chain? You know, there is a kind of mantra in business management, value. I could talk for hours, not for hours, but for quite a long time. There are problems in the meaning of the English term of value, but my suggestion is, and the same time question, the question that you could impose economic processes or value creation or value diminishing on this simulation system. Like you, for instance, have in the critical path method. Then you put value cost, CPM cost. So what is your opinion about developing this? It will be quite interesting in this case, because as I understand, this is the software which could be used for many, many other purposes. And in this case, it could be, once again, what is your opinion about extending this software, this model for counting value, assessing value? And my second point is that perhaps the transaction costs could be useful here, because it's just another point. Thank you. Jakieś inne pytania państwo macie? Any other questions? If not, proszę odpowiadać, jak pan może po angielsku, jak wie, dlatego, że tu mamy gościa, uczestnika.
Okay.
Proszę bardzo.
When we solve these projects, we have idea, and in municipal waste, it is very interesting that when you put under your house or buildings your waste, you are still owner of this waste. But when take it, for example, in our subject, incineration factory, you will pay for this, that somebody take your own waste. It is very interesting. Then the activity which is connected with the collection of the waste is very interesting, because owner of the waste will pay of this all activity, and the value of the materials after separation from the waste are money or value for the incineration company. It is very interesting system, and during solution of these projects, I understand why mafias families in New York still want manage of the waste companies, because this is very good materials source, and source for never-ending money. This is my opinion. And what about solution and compare of the results after solved these projects? After simulation, we can say that better is total separation than incineration. Because we can use many good materials for the new processing.
Okay, so thank you very much. We have, we are almost exactly on time. Any other question? Państwo macie jakieś inne pytania jeszcze, komentarze? Okay, yes, please. Okay, please.
Thank you very much for your presentation. I'm an international visitor here. And I want to ask, in your engineering process...
I invite to Košice, please.
Okay, thank you. In your engineering process, did you consider another resources impact? For example, separation of waste, it's also require a lot of water, a lot of energy. And did you consider these facts, resource interaction and resource impact? Thank you.
Now is in Košice with incinerator factory situation is that all waste is combustion or burning, and energy from the Košice waste or waste of Košice is able fill all necessary requirements for all Košice for energy and heat too. But economy or system and management of this incinerator factory must manage this combustion, and many heats is output to the air.
Okay, it's okay.
And
okay,
it's not used for the, or is not better utilized for the citizens of the Košice.
Jakieś inne pytania mamy? Nie widziałem. Okay, any other questions? Nie ma. Okay, panie profesorze, jeszcze raz dziękuję. Thank you very much. Dziękuję wam. Dziękuję wam. Dziękuję panu bardzo za bardzo pouczający, bardzo ciekawy referat. Tutaj ogromny, jest to duży wkład do naszego projektu, no i liczymy na dalszą współpracę, prawda? Tutaj pan doktor Małkus. Jeszcze raz serdecznie dziękuję panu bardzo. Dziękuję państwu bardzo.
Bardzo dziękuję, pozdrawiam i ja przyjedę w wtorek na konferencję i możemy rozmawiać i dyskutować dalej face to face.
Bardzo cieszymy się z tego, bo to naprawdę jest... Tam byłoby jeszcze wiele innych kwestii, ale wiadomo, zostawiamy to na jutro. We'll leave it till tomorrow.
Dobra.
Professor will arrive tomorrow, so you can exchange the views, you can discuss tomorrow. Okay. Dziękuję panu bardzo jeszcze raz i teraz...
Również bardzo
Jeszcze
dziękuję.
dziękuję
Bardzo
bardzo. A
miło
teraz-
było rozmawiać z wami i prezentować.
Dobrze. Teraz no, ja sam mam się zapowiadać, że tak to wyszło, ale to niech będzie, to jest ta złożoność. Panowie, możecie dać tę moją prezentację, bo ja tu jestem bezradny. Ja tylko zobaczę, czy to urządzonko działa, bo to z reguły te wszystkie wskaźniki. Byłbym wdzięczny, tam to przekazałem. Tutaj mamy, czekamy. Na razie. O, jest, dobrze. Żyje. Teraz jeszcze sprawdzam, czy nawet żyje ten pointer. Ja sobie tutaj stanę, żeby było wygodniej. O, nawet laser działa. Szukam takiego miejsca, żebym mógł, ale żeby jednocześnie być widocznym, żeby taki kąt jest troszkę ten. Dobrze. Proszę Państwa, teraz ja w imieniu naszego zespołu, I will be changing from Polish to English constantly, so it will help you. On behalf of our team, I would like to present our paper, the result of our part of the project. Once again, I want to emphasize the role of Professor Mariusz Sołtysik. Dziękuję panu bardzo i tutaj mam już co będziemy mówili, ale na tym polega istota pracy naukowej. Jak popatrzymy na historię, to czasami wkład pracowników nauki i ich wysiłek był bardzo, bardzo duży, a potem osiągali rezultaty. I just express my gratitude to Professor Sołtysik, who was a chair, the boss of our team. Okay. Proszę Państwa, tutaj mamy to, że Agile Project Management Complexity, oraz złożoności w podejściu metodologicznym Agile w zarządzaniu projektami. Oczywiście to jest tylko krótka synteza wyników, dlatego że to by długo na ten temat można rozmawiać. Dlaczego tak się stało? No, uzasadnienie to podam po prostu założenia tego projektu. Oj, bezwładność ma, albo przestał reagować komputer na mnie. Zgodnie z prawem Murphy'ego i złożonością nie reaguje na przesuw, a działa, ale powoli. Ma dużą bezwładność, jak widać. Chyba że pan to... Tu mamy tę formułkę, więc to tutaj nie jest... Czyli nie reaguje, rozumiem, to będę prosił o zmianę slajdów, dobrze? Jeśli tam coś, albo bateria, no złożoność świata, wiadomo, to tutaj gorzej jak to był tylko z satelitą, albo tak, samolot z 300 pasażerami, wtedy takie coś tam i sternie działa, ale to jest ten. Idzie? O, jest, dobrze. Ale ten, proszę Państwa, to jest mój działa? Z dużą bezwładnością, no, kieruję w stronę Pana. O, działa, dobra, teraz, bo tam coś się przyblokowało, teraz działa, to jest wszystko bezwładność tego, dobrze. Inertia of the pointer, signals and okay, complex. Proszę Państwa, to jest zespół, this is the team of the authors of this part of the project, then okay, okay. And this is the book, the main result of the project published by Routledge, and this is presented as a kind of first edition. It's, being quite frankly, this the part of the market, the low issue books, but they are quite influential, and I think I recommend to get it and to read it. Okay, good. Okay. And then the second book, druga książka, tu jest rozdział dotyczący przemysłu 4.0. Tu jest ta ogólna książka, która, prawda, jest efektem pracy zespołu kierowanego przez naszego rektora, magnificencję rektora. To już jest kierunek rozwoju. Plus był jeszcze szereg prac, które tutaj nie wymieniam, na pewno tam. Łącznie z tym, że stało się przedmiotem zainteresowania Rządowo-Wojskowego Instytutu w Australii, gdzie 3 artykuły mnie zamówili na ten temat, prawda? I to, że tak powiem, to proszę Państwa, więc teraz tak, po kolei, jeśli można. Dobre, założenia projektu, these are the assumptions of założenia, że Agile Project Management was a kind of response to the increasing complexity of projects, teams, and methods of project management. Powstanie w 2001, czyli cała dekada lat 90., ale initiation to the year 2001, the Agile Manifesto, I put it in Polish, Manifest, the Agile Manifesto. I teraz widzimy tę ewolucję, wykorzystanie Agile, podejścia Agile we wszystkich obszarach zarządzania projektami. Evolution of Agile, Agile approach to other areas of project management. OK. Założenia. Tutaj okazuje się, że ja tak w pewien sposób, bo myśmy się tak podzielili rolami, ja tam większość spraw dotyczących złożoności, zespół dotyczący zarządzania projektami, Agile, się tym dosyć długo zajmuję. I można zauważyć, że wpływ tak zwanej complexity science, prawda, nauk o złożoności, complexity project, chaos theory, teoria chaosu, prawda, i to wszystko ma ogromne znaczenie, jak patrzymy na język. When we look at the vocabulary of Agile project management or Agile management, so there's plenty of that. I teraz tu, jak powiedziałem o tym wykorzystaniu doświadczenia członków zespołu, zobaczymy, ma to bezwładność, no naciskam. Bateria jest chyba słaba, ale to już... Dobrze. Pytania. Research questions. What was the impact of the complexity science, complexity research, whatever I may call it, na rozwój, on the development of Agile, prawda? What is the cognitive and practical value of application of the concepts related to the broadly defined complexity thinking, whatever we may call it, in Agile project management? And the question was just quite provocative, whether it was sensible, did it have any sense? Did it have any sense? Was it just sensitive? Otherwise, was it a fact or something valuable? So that's the third point here. And the answer to this. This question is was very actual in reference to the application of complexity thinking in management or in social science. Okay, good. Hypothesis, difficult to formulate hypotheses, so rather the conjectures, takie przypuszczenia, szerokie ten. The concepts that borrowed from complexity science played a very important role in development of Agile project management. Then what is interesting, that what is dominating right now is the analogies and metaphors. Of course, then the mathematical models, but in the process, not in the, I would say the process, in simulating the processes of the software development or project management. It came later. What more we have? Let's wait. Oh, this is lazy. Okay, good. What is this complexity theory? Another point is I've been involved in this for decades. And what I always expose, what I podkreślam, I'm not a specialist in complexity studies, by no means, no, it's nothing like that, nic takiego. Natomiast I know when people use the term complexity. So this is my area of research in social science. And when they use it, this is complexity in economics, no, because there are plenty of slogans and so on. So this approach was used or has been used to study the use of the terms associated with complexity in Agile project management. Okay, I will say more later. So what more? Here we have those terms: complex, complexity, chaos theory, self-organization, and so on and so forth. Well, there are plenty of terms: theory of complexity, complexity science, complexity approach, whatever. We don't know what complexity is precisely. So we study something, but it's quite an interesting problem from practical point of view. That a very catchy term, chaos theory. It was just an incidental name of a class of mathematical models. So nobody pretends that I'm studying chaos. And then, so as I've already mentioned, that we could observe a very strong impact on analysis and metaphors and mathematical models. Of course, there are plenty of them, but I will refer to this later. Which terms are used? Adaptation, chaos, the edge of chaos, self-organization, chaos theory, feedback, synergy, turbulence, non-linearity, emerging properties, complex adaptive systems. Right now, I will come to this later because after this I have plenty of invitations to write something I refer to those complex adaptive systems. The point is that usually there are mathematical models standing behind of those terms. And then the non-mathematicians using this, they may have different intuitions, different approaches, but it's very important in business management. Okay, so let me just, okay. What was in the book, in our project, we've developed a typology of applications of complexity-related terms in project management. In Agile and latent project management, this typology is useful in my further research, for instance, because it fits to all areas of social science. I will refer to this later. We use it, we can use it in our research, not only the mine ones. We may say that the first result of this project is kind of epistemological, methodological foundation for applying complex systems studies, I prefer this term, in different areas. And we focus here on project management on all potential fields. Here, this is the typology, the scheme of the typology. That's the kind of essence of this. It's all the types of, we can see that we could include complexity beginning from cybernetics, the relatively old concept, and ending with social systems of Niklas Luhmann. We have sociologists among us, the complex of system of Niklas Luhmann, especially in German-speaking countries, but not only. So this is the first. Then there is a typology of complexity applied in management. I'm not going to discuss in detail, it's in the book, or we can just discuss later. Then, Scrum and complexity. The first area that we've studied in detail was the origins of the concept of Scrum. Complexity, chaos, the edge of chaos, self-organization, they were the basics, the basic concepts borrowed by the authors of Scrum, Schwaber and Sutherland, in the 90s, and then they promoted this. They had promoted it in the early 21st century, and it's been still promoted. Scrum, you know that what is Scrum? This is taken from rugby. The term Scrum, we've conducted a kind of a deep archaeology of knowledge. It's very important when we look at management theory from the point, let's say, the language and the action. If we use the language, then we follow that it's followed by our actions. So we have to use a slightly deeper hermeneutics. In this case, this is quite successful. It's very promising in this part of study. So the metaphor borrowed from rugby, but it was borrowed by Schwaber and Schwaber precisely from the concept of the very famous paper of Takeuchi and Donaka, who followed in turn the works of Erich Jansch, the concept of self-organization. Then we've studied first the works of Sutherland and Schwaber. Complexity, usually we've coined this term of intuitive complexity. And the first area which we can see now, software development, turning to our colleague, Professor Tatiana, software development is intuition. Just complexity, for instance, that for Schwaber, into complexity, the methods borrowed from complexity studies were kind of methods of taming complexity. Well, we know that, so we can tame it, but they've operated at the level of intuitive interpretations. Here I've mentioned this. Then which metaphors they use? At the edge of chaos, self-organization, emerging properties, non-linearity, of course, and the very famous American concept of John Boyd, OODA, observe, orient, decide. It's the key of American military doctrine, for instance. Not only doctrine, but application begin from the tactical level till strategy. Then it was also, we've studied the link of the so-called stasis matrix, which is here, and it was pretty simplified in the applications of the first book by Schwaber. Stasis quite an was. He passed away last September. Then what is useful? So we now know the roots, the impact of complexity on the origins of Scrum, but we can see that it's still relevant. This approach, it's applied it's still relevant in extending Scrum. Scaled Agile framework, large-scale Scrum, and so on. What is interesting that Scrum and complex adaptive systems and complex software development were decisive in implementing complexity-related research to project management. So what we've observed that it's extended, as I've said, it's been extended to other areas of project management. And what is essential, what is important, if not essential here, is looking from the perspective of the year 2021, we can have a balanced, a very rationalized approach, so that is something also important. Then adaptive software development and complexity. Here we have Jim Highsmith. I can tell you a funny story about this, which is creating headache for the publishers. When he was younger, he called himself James Highsmith, officially. But later, when he grew older, he called himself Jim. It's pretty, maybe I was joking that maybe he married for the second or the third time, with a younger wife, so he wanted to be, instead of James, he wanted to be Jim. Okay, adaptive software development, that he played a very important, James Highsmith played a very important role in transferring complexity ideas to the Agile software development, because he had studied the basic works and he understood them. That's quite important. While Schwaber and Sutherland borrowed the idea, sometimes in a more or less superficial way, although of course I may not say that they didn't understand it, but it was slightly superficial at a metaphorical level. Highsmith had introduced those ideas also as the metaphors, but with a much deeper approach, with a much deeper understanding. For instance, so what is interesting, for instance, that he defined Agile as something, as a method of adaptation to the turbulent environment later, because the ideas of Highsmith had evolved from software development to management. I think there is another work. If we are successful in getting the second round of REV, then we have plenty of material. So, but what is interesting here, that I can tell you something which is very important for business management specialists, what can be seen on the case of Agile. In management, we are living in the era, I don't know how it's in economics, but in management, I'm going to try to think about this. We have many of broad ideas, value, Agile, and so on. And people don't know what they are talking about because there are so many meanings of those terms, so many interpretations. But what is interesting, those broad meanings, when decomposed, they are illustrated a lot of, almost an unlimited number of specific solutions. So there is a trap with systematic literature research. Because if somebody, okay, let's search for Agile, they would get junk, garbage. Because there are so many ideas with Agile, so we had to, because of that, what is Agile? I am in the prestigious journal, in International Journal of Project Management, they published a paper on complexity and based on the systematic literature research. So they've cited when they use the term complexity, everything. And it was bad, it was just the events of the method. So this is a very big challenge for younger scholars in studying management. Because the core of Agile in management, in software development, is this idea of Highsmith. That adaptation of the project to turbulent environment, and no further relation, no further reference to turbulence, what is turbulence, while in management, we have very well developed concepts of turbulent environment. It's another slogan. Complexity of Agile and complex turbulent environment. And our project provides a more refined language for this. Here there's a hypothesis. We have a hypothesis that James Highsmith was the in terms of in intellectual and in political terms, was the key person transferring complexity research to agile software development during that famous meeting in Utah in 2001 when the Agile Manifesto was developed. So we are operating at this level of analysis. This is not the history of doctrines because later I will show how it could be useful. So we hope that the second, if the team wants to work on this, you know, we could invite also the other. Okay, I control the time. Don't worry, I also control the time about myself. I'm very rigid about this. Here there is something, there's another result that, so then we could, it's only I showed a brief presentation of results, of a part of results, right? With that, there's something more. There is something that we should develop. Because if we know complexity quite well, and there's an example of software development. If we know complexity quite well, what it means, then, by the way, I used to be a programmer. So I'm talking a long time ago. I don't know anything about C++, you know, no, nothing. Of course, I know that something like that exists, but I know the rules of computer programming, right, of software development. So that we are not talking about something the abstract and so on. But what is it here? Why is it useful? And I think it's worthwhile to develop. That concentrating on software development, somebody says this is complex. Developing a very complex software for a very complex problem, for instance, AI, artificial intelligence. This is a direction of research has been already explored. Because first, they have to define the problem very precisely. Then they have to consider man-machine interaction. And then they say, okay, let's use an agile pattern of project of software development. This is true. This is true, exactly. So what is leading to those things? And this table is a kind of self-reflexive approach, self-reflexive pattern. First of all, the project management or somebody who is developing software must ask himself, herself, or by themselves, what does it mean complex in this case? What does it mean complex at each stage of the software development? What will it mean complex, for instance, in the most sophisticated thing in this case, but invite others for cooperation, by developing software for AI, for instance, so on. So this is the kind of signal of the project. And so now I've expressed that this is, I wanted to, this is the table, this is one of those first tables. Of course, and then this is this core table. This is an introduction. Sorry, I'm not going to read it because it's not illegible but difficult to read, but you can see levels of knowledge about complexity, and here we have levels of complexity. So levels of knowledge and levels of knowledge of complexity. That's why those Australians liked it as a part of this. Low, medium, high, low, basic, medium knowledge, whatever. Because instead of chanting the slogans, it's necessary to do this. So, okay, good. Then the results. So what were the results of research of the team? The history, that I've already mentioned. Then a very profound study of genesis of implementation of this project. Then this typology, for me and for the rest of the team, but the typologies is very useful. It can be applied almost everywhere, and there's something that now I have plenty of orders of text about complexity because the word is getting complex. People don't understand. So that I can tell you a funny story because complexity and chaos have a deep psychological sense, and it could be abused by consultants in management. The word is chaotic. There is uncertain. And then comes the guru or a guru. Look, I'm a specialist in complexity. I will help you. Have my consolation. And it's working. Security studies, though I've said that I'm not going to go into detail. I have, let's say, more than 5 orders to use this pattern in other areas, of course, and the team is ready to continue, but I'll count. Then a preliminary assessment of the role of agile, of complexity in agile project management in all areas. We have also a kind of methodology standing behind this project. And as I mentioned, also the status quo of Agile. Let me just. Then we have the further research. Definitely, this project is worth continuation, either in a series of papers or in the book. We'll see what will be the commercial response of the book. You know, this is the specific segment of big international publishers, but we are waiting for a signal from them, but I think maybe in a couple of months we'll turn to them. Can we develop this in a series of papers? Of course, we could also invite our authors, that we could go that deeply, and on the other side, we could go to large-scale projects. Then assessment of advantages and disadvantages of propagation, of promotion of Agile approach in broadly invite management. Here I would like to expose the role of Dr. Maukus, who had developed a very deep research on the meaning of Agile in management, you know, all the genesis. Because what we can observe is not only Agile project management, beginning from the software development and ending with all kinds of projects, but Agile management. My company is Agile, so what? We are Agile, but so what? Please tell me precisely. And then, oh, we are adapted to turbulence. What does it mean, turbulence? Turbulence. So it's quite interesting. It's very important in consulting, that you can sell your consulting project goes training, but just saying, look, this is turbulent, and it's working. No, it's good, but it could be raised in the questions. So this methodology that the skeleton is included in the book would allow to avoid this simplified and kind of slogan-like approaches. And I think that is all. I didn't put the slide. Thank you very much. Dziękuję Państwu bardzo za uwagę. No i tak sam sobie, to ja może, no nie ciężkim tak sterem, okrętem, bo to będzie już samorefleksyjność trzeciego rzędu, to może poproszę pana profesora Sołtysika, gdyby jakieś pytania były, że pan...
Jakieś pytania? To moja prośba jest taka, żeby spróbować powiedzieć sobie, czym jest to Agile. Bo no, z racji tego, że zajmuję się zarządzaniem projektami właśnie w obszarze inżynierii oprogramowania, to spotkałem się z tym pojęciem wielokrotnie. I szczerze mówiąc, najczęściej spotykałem się z nim w takim znaczeniu zdrowego rozsądku. Myślenia, ukierunkowania na cele. Generalnie można powiedzieć tak, jak ktoś działa nie według schematu, tylko według tego, co ma w głowie, to jest Agile. Co dla mnie budzi pewną, tak powiem, wewnętrzną sprzeczność, bo schemat to jest jedno, a myślenie to jest drugie, a Agile to jest jeszcze coś innego. I to jest takie jakby pierwsza rzecz, pierwsza refleksja, mniej więcej też pytanie właśnie, jak rozumieć to Agile w tym momencie, bo to nie tylko podejście iteracyjne, to jest troszeczkę więcej tych elementów. I druga refleksja i też poniekąd pytanie. W ostatnim miesiącu spotkałem taką ciekawą publikację bodajże w Harvard Business Review, której autor stwierdził, że te 20 lat Agile'a w zarządzaniu projektami, tak naprawdę jedyny sukces, który odnieśli, to producenci kolorowych karteczek na tablice kanbanowskie, czyli tak zwanych sticksów, a reszta to jest po prostu mówienie tego samego w inny sposób Czyli tak jakby odrzucając całą tą koncepcję. Bo oczywiście ta koncepcja, jeżeli się popatrzy na Agile Manifest, to tam z niczym się nie można nie zgodzić. Ale to jest chyba właśnie myślenie. Stąd to pytanie, jak byśmy chcieli zrozumieć tego Agile'a?
Okay, I have a question. Concerning the environment of agility, what do you think? What are, maybe you can identify main important features of complexity influencing a way to develop projects in iterative, incremental way? You know, the approach to project management, IID, iterative, incremental development. And what do you think about main features of complexity influencing taking such a way, okay?
Thank you for presentation. I'm not a manager, I'm focused on energy sector. And you say about turbulent environment. So what about transition? Not concept, dimension, like transition. For example, in energy sector, we have transition from coal to oil, from oil to renewable, green energy, and it's also in process of very complicated. But they call this like one word, transition. Thank you, Professor.
Dziękuję bardzo. Thank you very much for the questions, very inspiring ones. And let me just to Professor, what are the problem of Agile? What was this? How to understand after this study, and after when we look, not only from a complexity perspective, from the managerial perspective, from the, as I've mentioned, from somebody who knows what software development is. As you know, I have a background in physics, and I'm still active in physics, so I know how it works. So when I could answer, how I could answer to this, what was Agile? In the 90s, we could it was possible to observe something like this, increasing complexity, this slogan. But in software development or in project management, new phenomena occurred. Earlier, they applied that the most common were the linear approaches, you know, to some extending, yes, then all those, let's say, the unfolding, you know, then the waterfall and so on. The key problem in this for me was how to deal with the smart, intelligent people, how to improve their work. The teamwork of smart, intelligent people in solving their problems. A software writer, a programmer is somebody who just wants to solve a purely mathematical problem. Of course, now, so for me, as I understand software development, and if you deal with those people, they are smart, they are sometimes capricious, and so on. And it turned out that the classical linear or more or less linear methodologies didn't work. Then came what? Then came the applications for the mobile phones. When I was a programmer trainee a long time ago in the US, and then I developed my program, my software for my PhD thesis for a network model. So how it was working? The software was ready and was working for quite a few years. Then small improvements and so on. But the development of hardware forced, and then the mobile phones, applications, and forced the programmers to cooperate constantly with the users. So just another challenge, you know, to cooperate constantly with the users. And then there were several approaches called under the common label Agile. There were, let's say, at least 10 or more software, this, and that. I've mentioned only a few. And then, what was the coincidence? the development of the language of complexity theory in the 90s, it was a peak. And then those authors, Sutherland, Schwaber, Sutherland, and Highsmith, they came, okay, we have something new, Agile. We had succeeded, you know, they proved that with the new approach, they could, let's give it a catchy name. So it's a kind of cognitive psychological level. Then I will come to practice. So this coincidence that I mentioned about created a new conditions for adapting to this flexibility, to the turbulence and changes in the environment. The point is this gap, in my opinion, there is this gap, broad language, and then very specific solutions in software and in management. So it started a new era, turbulence. And how is it working in practice? Firstly, you could produce nice, let's say, simulation models improving the work of the teams, of the project teams. That's the first area. But on the other extreme, when you train people, because it's especially important in training, when you tell to somebody, look, this is complex, and I give you some reflections, and if somebody is sincere, not a charlatan, so maybe those people are inspired in a better way. Sometimes those slogans could be helpful in improving their activities. So due to the scope of the meaning of Agile, you can criticize it, that it gave nothing. I liked very much your comment that this color that sticks, you know, that they post-it. My observation was that Agile is sponsored by the producers of the post-it sticks. Because when I visited a few years ago, 2 or 3 years ago before COVID, I visited a top-level Agile management company in Germany. Everything, you can lay, you can sleep, you know. I didn't ask me to, should it be in the Netherlands, then maybe a good possibility to smoke something attractive. In Germany, there wasn't something like that, you know. So this is the response of this flexibility, and we can say it's nothing. But on the other hand, looking from a deeper perspective, I think that this is to make people aware of their their daily language. Because what we say, and another project is about complexity and ignorance. And if people don't go deeply into the meaning of the words, they don't understand the word. We can observe it right now. That people don't understand. Majority of people don't understand what is going on in the world. So this is like, and we could talk for, I said, is it for training? We are persuasive. Look, they have resigned. What is interesting for us at the edge of chaos? When it was proved that the metaphor of the edge of chaos was erroneous, was wrong at the level of mathematical model. And that was a nice metaphor at the edge of chaos. A very influential lady, I admire her, Kathleen Eisenhardt in management. They wrote together with the chief, I controlled the time, don't worry, with the top-level manager of Google. They wrote the book, Company at the Edge of Chaos. You know, imagine Kathleen Eisenhardt from Stanford University and the top-level boss of Google wrote something about edge of chaos. So the entire world, the companies all over the world had become at the edge of chaos. A beautiful metaphor. It turned out that this is completely wrong. I mean, the metaphor is, the base of metaphor is, the source is incorrect. So Agile specialists refrain from using the concept of the edge of chaos. So I could talk, so summing it up, it's inspiration and new language, and it's also reflecting, and sometimes it's useful just in persuasion. And the last point here, in this case, is that, for me at least, good programming, developing of good software, or good understanding of AI with sufficiently profound, refined language could be counterproductive. For instance, self-reflection, self-reflexivity of the machines and so on. I'm going quite far, but it's not, I don't invent this. There is a series of works on this. So we can say it's nothing, it didn't work at the level of slogans. So it's my, of course, I could talk for hours, how we can understand that environment of the environment of the Agile is this turbulence, the slogan of the turbulence, the increasing predictability, and so on. And sometimes it's this increasing predictability is enforced by, let's say, the applications for mobile phones, which are constantly updated, looking from a software development and looking from the point of view of corporate development, company development. So this is true. Now it's very difficult to make any plans. So people naturally, instinctively say, okay, we have to learn more, we use this term. And the key point is how to operationalize the broad terms of Agile and some other turbulence into some specific solutions. Okay, I cannot say, but now transition, another funny story. Incidentally, I cooperate also with one of the leading German teams on sustainability. I don't know too much about now I'm learning about sustainability. Truly, because now I have another right to assign the Anthropocene and complexity. I can provide some complexity. And the transition to sustainability. Incidentally, once again, my good colleagues from the Netherlands, they have developed this term, transition to sustainability. Because when you look closer in the systemic terms, what sustainability is, initially you could expect that there was a kind of stable state of affairs, but it's dynamic. But look what is interesting, if you know mathematics, the kind of first derivative. We don't know the sustainability, it's not so well defined. So if you don't know something, so let's invent the concept of transition to sustainability. And there are plenty of books of transition to sustainability. I'm not ironical, but it's necessary to go to a certain level of study. So whether this transition to sustainability, look from a logical point of view. We don't know what is. Sustainability is a kind of vanishing point, yeah, to some extent, yes, what is sustainable, for how many people now, and so on and so forth. And then we have to transition. So the first derivative. In mathematical terms, the first derivative, pierwsza pochodna. To jest po prostu pierwsza pochodna. Tu mamy not even the second derivative, because sustainability is dynamic, it's kinetic, so you have speed, the first derivative, and then you have the second derivative, drugą pochodną, that's some kind of acceleration in the process of transition. So I wrote something about, it's quite very well sold, complexity and sustainability, and now I'm going to using this terminology, using this methodology, I can develop more. Okay. Proszę Państwa, no to ja mógłbym godzinę opowiadać, starając się porządkować to wszystko. Oczywiście to może być krytykowane. It could be criticized, but it's a very fascinating. We've joined with this team, in this way we've joined the team, the level of those things being applied at the world level. So here we have the logistics, then protection of natural environment, but there is a lot of work, a lot of inspiration. Zapraszam. Dobrze. To tyle, proszę Państwa. Nie wiem, jeżeli byśmy jakieś, czy mogę jeszcze coś, to przewodniczący, bo czas się da.
Dziękujemy, zrobimy teraz przerwę do 11:30.
Proszę Państwa, w tej chwili rozpoczynamy drugą część naszej konferencji. Mianowicie tutaj mamy dwóch panelistów. Przyjęliśmy, że będzie to w formie takiej dyskusji panelowej. Potem proszę o udział w dyskusji. Będzie to po polsku, ale ewentualnie tutaj paneliści będą starali się też część po angielsku przedstawić, tak w sposób mieszany. Temat tego panelu Social Robot Neuro, a New Approach to Management. I tutaj bardzo miło mi przedstawić pana profesora Bartłomieja Śnieżyńskiego oraz pana doktora z Akademii Górniczo-Hutniczej oraz pana doktora Artura Gunię z Uniwersytetu Jagiellońskiego. Trzecia osoba do nas nie dotarła. W takim razie ja mam propozycję, że panowie w sposób taki usystematyzowany przedstawicie swoje punkty widzenia na ten problem, a potem będziemy zapraszali uczestników tutaj do dyskusji, komentarzy, pytań. Mamy bardzo dużo czasu, bo do godziny 14 ale oczywiście nie będziemy tutaj na siłę tego przeciągali. Także proszę bardzo, pan Misiusz, proszę bardzo.
So should we speak English, I think, because we have here one guest. Okay, so it will be a little bit in Polish, a little bit in English. Probably some words will fall in. Okay, so the main question of the opportunities and problems dangerous about robotics is that we should divine in that robotics is not a general problem today. So we should distinguish the way how we understand robotics. Well, in the basic understanding, I think that starts in the early 40s in last century is robotics in industry. So we often got robotic arms, and in this understanding, robotics mean that the robot do such a work which is very continuous for humans. So, for example, for 24 hours, do the same thing. Also, these robots are created for this that do work which could be dangerous for human. For examples, we got these robots in some spaces like deep water abyss, when can do some difficult works, and also we send into space the robots, for example, on Moon, on Mars, to do such works which cannot human do. So this is the basic understanding, I think, for robots. But in, I think, early 80s, 90s, we got another group of robots, which is social robotics. It's a very different group than the robots for manufacturing, because they should be agents that help people in each days in very normal situations. So the task for these robots is, for example, babysitting or being partners for elder people. Also to do some work like in the reception, for example, in hotels, hospitals. Especially this was very important during the COVID-19 pandemics. For example, when you go to the hospital, and social distancing was very important. A lot of people was in this time sick and absent in the works, so the communication with this type of robots will be very important. And in this group of social robots, we got non-humanoid systems like assistants. I think we know such a system like Amazon Alexa, but we got also some humanoid agents, robots which are quite similar to human body. And in this group, we got, for example, such robots like of some of the industry, SoftBank robotics, like Robot Neuro, Robot Pepper, with which we also work in our scientific works. These robots looks quite similar to humans, have legs, arms, and what is most important, they have the ability of communication in natural language. In some persons, some understands, for example, our question, and quite good answer on this question. Of course, inside the robots, not only the embodiment is important, of course the body is important, but the most important factor is what type of artificial intelligence we use in such a system. So the natural communication is important, but also some non-verbal aspects are very important. So what are the robot behaviors, how the robots behave, for example, what could be the gaze, which is meaning the eye contact with the person, and this is not a trivial situation to program these things. We mostly use some machine learning system. I think more in details Bartek will say about these problems. But these behavior aspects are very important. And another factor in this, this social robotics, which is also important opportunity, is how we design cognitive aspects. So how the machine could learn from the environment. So how can learn some new situation. And in this case, it's also important if the new situation, for example, when the robot will replying to us, if this is adequate to our to the situation. So such a basic example could be that a robot could remind, for example, the name, the age of the person in which they communicate, could recognize, for example, the face, and for example, when somebody will join the robot again after, for example, 2-3 days, the robot will know that this is the same person, will know some basic information about the person. And the most advanced thing related to social robotics, especially to the humanoid robots, is to recognize emotional states of the human. So we want to build robots which recognize emotion. Of course, we don't want to have robots that have emotion, because we don't want to have robots which are angry or lazy, but we want to understand our emotion, to have better this interaction, communication with this robot. And of course, in such a way, this is not only informatics, computer science, and robotics problems, but it's also related to such a disciplines like psychology, cognitive science, also philosophy and ethics, because we can, if we for example, recognize emotion, or in a badly way we answer on the emotion, that could harm the people and could do very lot mess. So it's important how we recognize the emotions. So this we could do also in a lot of way. The most basic way of recognizing emotion is related to the psychological approaches, especially to recognizing emotion from the micro expression on the face. This is related to Paul Ekman theory. He described 6 types of basic emotion. Of course, Paul Ekman doesn't do this experiment with robots, but on some people in Papua Nova Guinea, which they recognize this basic emotion, fear, happiness, discuss, anxiety, happiness, and probably and anger. These are the basic. So is it possible to recognize these emotional states, because each states have a different pattern when we look at the muscles on our face, and even robots could very quickly recognize these states much more quicker than human do. do. But this is only one of the theory of recognizing emotions. We can also recognize the emotion from the voice modulation, from the behaviors, also from some biophysical factors like heart rate, skin galvanic response, and this. If we want to all this factor take into account, we should recognize robot not only as one type of external agent, but a whole architecture and system which is combined, which a lot of devices, which gather a lot of data, because the most important factor is to gather data and then to give some relevant conclusion to this. So this was the second group of robots, and in my opinion, we could also recognize a third group of robotic system, which may be on the when we first time we heard about this, that maybe we don't think that there are robots, but in this group we could put all automatic systems. Sometimes we call this autonomous system, but I think from the philosophical point of view is a bad word, because it's hard to, for example, recognize that our autonomous car could be self-conscious and aware of themselves. If we have such a system, then our car could say that he will go in this place because it's clean, and don't want to go because today is raining. In this way, we will have autonomous, but I will more use this automatic system. So in this group, we got all this system which are near us. Use mostly the idea of Internet of Things, which means that gather a lot of data, and is not only one system, but is a lot of external systems that could gather different signal. So in this group, we have this automatic cars. Today we don't have. Maybe in some research we have. On third and fourth level of automatic cars, but wholly automatic cars we don't still don't have. In this group we could also put some automatic drones and other devices which do for us some work, and they even don't there are, I would say they are in the ambient way, which means we don't need to realize that these systems are some robotic way. So I will say that we have three groups of types of robots, which are this manufacturer robots, social robots, and automatic system. And for each of these robots, we have different opportunities, and we can see different threats that could happen. But I think that now I can give the floor to Bartek, and maybe you can say.
Thank you very much. I'm computer scientist, so I will talk from this point of view. So maybe I will start my talk by explaining how algorithms have changed related to robotics. At the beginning, robots, when they were mainly used in factories, these robotic arms mentioned by Artur, they were controlled by simple search algorithms. So the environment in the factory is usually controlled. So it is relatively easy to design the algorithm for the robot because the robot can expect where is the object that it should grasp, where it should be moved. So such simple algorithms are efficient. When we move robots to other environments which are natural for us, like these social robots which we can put to our offices, hospitals, or even our apartments, or these automatic cars or drones, they can move along our roads. The environment is completely different, and it is not possible to use the same techniques that were used before. And this is where these machine learning algorithms are used. We can notice the difference between these two approaches when we observe, for example, the progress in natural language understanding. The research in this domain started a long time ago, over 50 years ago, but progress was very slow because these techniques that were used were not efficient. When when researchers started to use machine learning algorithms, it was possible to build algorithms that we now use in our smartphones, for example, and they work pretty well. The same is with image processing. These traditional simple techniques used before were able to detect very simple objects in controlled environment. So industrial robot was able to detect some box that was placed on a specific place, like a table, and move this box to the given place. But these algorithms cannot be used to process images of, for example, human faces to detect emotions. These machine learning algorithms give us opportunity to process more complex data, like voice signal, images, but also there are a lot of problems related with that, because when we design our algorithm by humans, we have full control and understanding how it works. Because we can, for example, create some rules that control the robot. When we apply machine learning algorithm, the knowledge is stored usually now in neural network, and it is very difficult to understand what this neural network, what's the knowledge of this neural network. And this may lead to many problems, because for example, such a neural network can make mistakes which are very difficult to predict. There is a story from the beginnings of the neural networks when it was used to discover tanks in the satellite images. So researchers prepared training data which contained pictures with tanks and pictures without tanks. And results of the neural network were very good. It learned how to recognize tanks, let's say in the forests, somehow hidden on these images. But after very careful analysis, it appeared that all the pictures with tanks were taken when the weather was poor, and pictures when there was no tanks were taken when the weather was nice, it was sunny. So it appeared that the neural network learned how to discover good or bad weather, not the tank. So it gives us the idea how many mistakes we can make when we are using machine learning algorithms, because they are very biased to this training data. Another problem could be that when such a neural network or other machine learning algorithm is trained, it has a lot of information that is related to our privacy. So, for example, now they are not robots. We can analyze it observing how huge companies use data that they collect when people use their software. So, for example, Netflix is able to predict what movies we would like to see or not. Amazon is able to predict what books, what things we would like to buy. Google knows what we are searching, so it can also build our models. So every company can create some model of the user containing personal information. And the same would be with social robots that will that we can meet in offices and maybe in the future also in our apartments. They will be collecting a lot of data. So they will be able to build our models. So the issue is to have some control of these models. So they, of course, should be very well protected because we wouldn't like to hackers to get these models from the robot and use them against of us. And another issue is that we would like to have some control of these models, because a robot could learn something that was in the data, but could understand it wrongly, like with this weather. So, for example, he could observe us that we are always drinking water when it is hot, and then it could create a model that this person likes only water, which is not true, because, for example, there were some other reasons why we have drinking water, not a beer, for example. So such adaptivity that is necessary to have robots in uncontrolled environments makes also a lot of problems. And another issue, which is maybe not related to computer science, but more to economics, is that we observe a huge progress in development of these automatic systems like automatic cars. For at least 5 years, there is automatic truck driving across United States. There are automatic taxis in United States, and I have seen recently also in China. There are automatic there are robots in Amazon magazines. There is also some seaport that most of the transport is inside of this seaport is done using robots. So even if we focus on this transport domain, if the progress will be such big, in some years, maybe 10, maybe 20, it's very difficult to predict, we can get cars that could operate on the roads better than human drivers. And we can have a problem what to do with people who work as drivers, because there are many hundreds, millions people working on this logistic area across the globe. And if it will be automatized, we would need to find some work, some other areas for these people. And such a problem can be also observed in other domains, because we have automatic doctors. They are not embodied yet, so there is no robot that can be considered as a doctor, but there are algorithms that perform very well. For example, there is a system developed by IBM that is used in veteran clinics in Florida, that when they compare its diagnosis with diagnosis given by human doctors, by consilium of doctors, the agreement is over 90%. So they are related to cancer treatment, and they are much better than the doctor, the average doctor which we can meet in the hospital. Similar problem could be with law, especially in United States, when a lot of young lawyers are hired to search cases similar to one that we are analyzing, because when they find some precedents, then can use it in the court. And there is also quite a good algorithm that is able to make such a search automatically. There are also algorithms in other domains, so I think it's a good moment to think about this problems which we can have when more and more automatical and robotical solutions will be introduced to the market. And even now, when we teach our children in schools, we should think about this, that when they are grown up, the situation on the work market could be completely different than now. Okay.
Thank you, Professor. And now I think it's good time to start the discussion. We have plenty of time, but we have so many different issues, probably so many questions that I think we take a chance to ask our panelists to help us to clarify some points or to share their reflections. So please now, who wants to be the first? Yes, yes, please. But I think it's easier.
Yes, thank you. I have two reflections about this, what we are talking about. The first reflection is that we are talking about voice recognition or picture recognition or something like that. But in the real, we should understand that computer algorithms don't see a picture and don't hear the voice. He just processing data which we obtain in algorithms we use to process some representation of pictures or voice or something like that. So it means that they are limited to the information we gave them. We almost never gave them the picture itself. Okay, there are some attempts to this, yes, so-called deep learning, when we are trying to teach the system based on the just bitmaps, not the representation. It is the first thing, so I think that this is kind of limitation of such a system. And when we are talking about using machine learning, we should always remember about it, that we do not learn them, this machine learning do not recognize the picture. It recognizes some schema in the data. And the data are prepared by us. So this is the first element. The second,
can I add ad vocem to this? Well, I think that when we think about also on human mind, we also recognize patterns. For example, babies which learn recognizing the word. So first they learn, for example, eyes, nose, mouths, recognize that these faces that they know, so they first recognize, for example, the matter. So we can have a little bit analogy between this learning, that in our way we also in some ways learn on the pattern. Of course, the learning on the pattern is different in our mind, and also a little bit different when we look on computer science.
Yes, but I think that there is a little difference. Or we can go so deep that we can maybe find that there is no difference. But we can assume that when we using our sense, we see the same picture, and of course, based on the external sources, yes? We see the picture, okay, we can see the different color a little bit based on our senses, but we see exactly almost the same. We've got the same information, the same data. Because later we made some processing of this data, but input data are the same. This processing data in our mind is based on our knowledge. In case of machine learning system, we process this data before the input. So we make some alternation to this data. We prepare, find some attributes and so on before they go into the system. It's when we want to compare with human, it is like we have 5 people, but each of us use the different color glasses, yes? So we see the different picture. So when we are talking about systems as a whole, we must understand that almost all of this each of this system is based on different kind of different selection of attributes which are used in process of learning, based on the goal. Yes? In case of the mentioned autonomous or autonomic cars, yes? For cars, there's no important, it is the tree or some kind of building. It's a kind of barrier which is stable, do not move, yes? And it is enough to take the decision. So we need a system which just divide the environment on the moving or not moving objects. And then we can go with further thinking. It cannot see the scene as a human. It's a kind of limitation, yes?
I agree that in some applications, or maybe in every application, there is some limit. Because now in image processing, mainly these deep neural networks are used, and they can get the full image containing a lot of pixels and analyze it as a whole. But the limitation could be that when this neural network was trained, it was given only examples of selected types of objects. So, as you mentioned, human can discriminate hundreds or thousands of types of objects, and it knows that, for example, the tree usually is not moving, but when it is very strong wind or it is somehow damaged, it can fall, and then it should not be recognized as a stable object. So
this is our knowledge, and
yes.
Maybe, but this is the question. Yes, maybe this system, if got enough examples on the input, will gather such a knowledge. But the question is how many neurons he should have inside to gather such a kind of knowledge, yes?
Exactly.
Now so they are very limited.
Right. So they are able to process images quickly to drive a car, but they make sometimes mistakes. So fallen trees could be one example, but I'm sure that we could also develop many other examples that such a automatic driver could make a mistake. But on the other hand, humans also make mistakes. And when we analyze what is safer, we should take into account also probability of such falling tree. And so far it looks like automatic car will be safer than human driver.
Yes, but I think fully agree. I think that it is, for me it is obvious, because the automatic car, as it is, or autonomous, name is not very important, behave in a deterministic way. So it means that he's never sad, never happy, he do not look around and so on. So he can drive 24 hours per day with the same behavior. So for sure it will be much more safe. But let's realize that we have three different kind of environment. Yes, we have closed environment. Mentioned that robots, for instance, is some ports on some fabrics. When in a controlled environment we have fully robotic, also transportation. We have semi-structured environment, like our cities, yes, when we are just now trying to learn the autonomous car, how to move in an efficient way. And we have uncontrolled environment, I don't know in English, bezdroża, or in the middle of nowhere, yes. Village road, yes, without lines and so on, where such as systems are simply unusable for us for today, yes. They cannot do anything, yes. So I'm sure that during 10 years we will have some automatic transportation. But I think that it can be obtained only on main roads and maybe in a semi-controlled environment. But I had a question, because when you are talking about semi-controlled and controlled environment, we have the railways, which is totally controlled environment, yes? Why we do not use autonomous trains?
Non-autonomous intelligent human being is wilderness.
Why we do not have autonomous trains?
It's a very good question. I don't know the answer, but probably the reason is some regulations. So I'm sure that it would be possible to create algorithm driving a train. But your question also, we were talking about autonomous cars, but similar problems would appear with social robots. If they are working in our apartments, mistakes could be even worse. So I remember that on some presentation, the creator of this Pepper robot, which we have at our institute, had a funny story about a robot reminding his owner in the presence of his girlfriend that he didn't answer for email from his other girlfriend because it didn't understand the context. So such problems are very difficult to take control of, because in our everyday life we use a lot of knowledge which we don't know how to represent in algorithms. So we need to be careful with these social robots.
Are there any questions, comments?
The same question as Professor, because
But it's recorded.
very loud.
But it's better to be because
No,
you
because
don't.
I'm
Okay, good. You are okay. Good.
because I'm not good in foreign language. Okay, and this is my problem because 20 years ago it was first program, for example, to translate our thoughts and writing things. But it was 20 years ago. Now we have the same problem with communication in foreign languages. I don't understand why. The same like with train, artificial intelligence, and the same
same in the other language. This is the problem, because these algorithms were very complicated and very poor. But now we replace the thinking about the translation. We are not trying to create the algorithms. We create the algorithms which create the algorithm. We go on the other way. It is the first step. The second step is connected with internet, because this algorithm needs a lot of data. Because when we had millions of internet sites, many of the sites have the same content in different languages. You can use this data to learn translation. And when you compare the Google Translator from even during last 2 years, you can see that there is a lot of improvement in the quality of translation. Why? They have a lot of data, so they can learn this, and they have also the reverse information from the user. Yes, we are sometimes make the correctness, so they gather this information and can use it. So I think that in that case, I think that maybe 5 years, and such a meeting like this, each of us will take the phone and talk in every language all over the world without any problem.
And even now we have software that works like this, and there are also devices that can be used to translate online. I'm not sure how well they behave. I have never used it, but they are available on the market. But I would like to add one more thing related to this new approach, this machine learning approach, that the key is the data. Because algorithms are more or less known, and many companies can create software learning to translate, but big companies like Google or Microsoft have data, and also they have processing power and money to process this data. Because now training or learning the language model needs a lot of computational power, and it is very expensive. Learning such a model could cost, let's say, $10 million. So huge companies have money to create such models, but small companies, it is too much for them, and also it's one of the problems that it will be difficult to compete with huge companies.
I think that now Google is the leader for the very simple reason, yes? They have a copy of quarter of internet, yes, on his servers. So his data are collected. It's the problem of users, yes? The other must collect this data starting from the beginning, yes?
Okay, any questions or comments? Yes, please.
One more question, because you have mentioned some professions that might be treated as risky in terms of replacement by robots. So if you maybe a little bit expand on this, what are the professions that in a, I don't know, midterm or long term could be most probably replaced by robots? So how we can perceive this feature?
Okay, so this is a problem. It's come from the, I think, even 19th century. So this basic works will be, in the first case, replaced by robots. For example, when we got to shops, we got a lot of this automatic cashiers. This, I think, in shops the cashiers will be replaced. Also, this a lot of people working in security, we will have a very good CCTV TV with some system with recognizing faces, which will be, I think, connected with some government system. So if somebody stole something, we will have this information immediately. I think also in such a profession which needs more advanced, could be also replaced. For example, in medical science, in my opinion, I see that radiologist could be in the first way replaced, because this is based also on some patterns when we have some tumors of the cancers. And we got a lot of pictures which are labeled as cancer, not cancer. Then I think in the future we don't need any specialist to recognize, because maybe the system could be even better than human. But on other hand, such a profession, for example, like teachers, like scientists, scientists will not replace it, because often if we put in some place a computer or new system, then often in one cashier we need to replace, for example, 2 persons which will be responsible for the system. So maybe from the economic way it's not so efficient. But I think the high quality will be safe. The low quality will be not safe. And for example, Israel sociologist and historian Yuval Harari will say that in the future, this person with some very low experience, low quality, then maybe if they will be replaced by the computer system robots, they will need some basic salary. There is such a idea, because for the people will be no job. No job. I agree.
Any more questions or comments? No?
One comment connected to radiology. Maybe a month or 2 months ago, I read the article, probably in American Science, when there was information that almost or more than 90% of medical support, diagnosis support system used in United States were never be tested clinically. So it's just working based on the word of the developer. It works. Okay. I think that this can be the problem, because I think that many of us met with the situation. It can't be done. The computer said this, yes? Computer said this, or computer said this, and there is no discussion. People are lazy. So when we replace people by computer, or support people by computer, the people very often switch off thinking. I'm just doing, the computer said I do this. And I think that this is the problem of such a diagnosis system, because we need a verification. We need a people, this is too serious problem, just to think that the way, okay, 90% is enough. I don't like to be in this 10%, yes? So I think that medicine is quite far away from the replace human by computer. Of course, we can use the computer to support. And just simple idea, we can show on the picture to which area the radiology should pay attention. Just look at this, because this is out of typical. So maybe something like this, support, not replace. This is the first, I have one more thing about the thinking about the jobs. There is maybe new kind of robot, not mentioned alone, because robotic process automatization. This is just software who replace the human in simply typical bureau office work. When we can teach or create or develop the software to do the human work, like, for instance, typing the invoices into the system, yes? And I think that this is also the area that very soon, maybe 10 years, the office worker will be replaced in many cases by the robots.
I agree. And one comment about the performance and accepting the algorithms, that we are afraid of solutions which are black boxes, and they just give the answer for given input, and we don't know how this answer was obtained. And from this point of view, these traditional solutions that were used in the past, that were based on the symbolic knowledge representations, were better. Because when knowledge was represented by rules, and these rules were used to give answer for a given problem, people were able to analyze these rules. So, for example, if the system answered that we should cut the leg of the patient, the doctor could ask why. And then the system could display a set of rules that were used to infer such a conclusion. And now, when more and more neural networks are used because they are more efficient, we are not able to display rules which are used to discover, for example, a tumor on the X-ray image. However, there are some works related to this problem, and there are a lot of progress. It's called explainability, where, and in this area, researchers are working on methods how to explain decisions of neural networks to the users. So not only give the answer, but also the explanation.
Thank you very much for your interesting talk. You say in beginning that robot can read our emotions. Can we make robots also emotional as a people? There are any research project or some big project to make robot emotional like people? Thank you.
Well, how I say previously, we don't want to have a robot with have emotion, but maybe we will have a robot which can simulate emotion. For example, if they could recognize that we are, for example, sad, in grief, then don't will say as a joke, or then can say very something very calmly to us. So this will be also a very important opportunity how we design some simulation of the emotional states, especially which will be relevant to this our feelings, our situation. I know this robots like Now and Pepper, if they can recognize, then could also reply. For example, if if they recognize for the face that we are sad, then can also have some face expression. Of course, it don't be exactly a face expression, but for example, they change the colors of eyes. For example, in our culture, blue is a sad color, so could change the color eyes into blue. But we also have such a robots which got mimics. This new robot, I think it's called Ateka, but also robot Ameka, and also the robot Sofia got a micro expression. So I think it will be such a connection if recognize in us the emotional states, then could simulate in similar way the emotional patterns. For example, on their face, we only need to agree what will be the patterns, the micro expression, the voice modulation, which could be, I think, relevant. So this is my idea to this topic.
I just interested in another last question. What do you think, what religion and church say about this innovation? They support, they agree, they accept, or they think like God creates only Adam and Eve and then we come, so how is it from a religion aspect?
It's also a very interesting question. I think that so far, at least according to my knowledge, they don't have answers yet. So it is relatively new area, and probably we need to wait for answer.
Because, for example, I was very careful listening, and you said that machines will only recognize our emotion, yes? Don't learn this emotion. Recognize this emotion, yes? And this is a problem, for example, religion is far away from that. But, for example, this is personality psychopath. We will enter our door of psychopathies. Because, for example, you are sad, and machine will see this, yes? That I am sad. No, that I'm very ill. That I'm very sacrificed, yes? And the result is one, yes? And this is a problem, for example.
So the robot will copy.
Yes, because free information, yes? Sad, ill, very illness, yes? And unhappy, and yes?
But this is the problem of data. This is a problem of data. We can think about the 6 basic fields, yes, but we must remember that these feelings can become from different situations. It's not the same. We are sad, but to react, you must know why I'm sad. Yes, and this is the problem, I think. But this is the problem of data. I think in many cases we go back to the problem of gathering data, of data processing, in a process of creating these algorithms, in the process of machine learning. Yes.
Also, this is a problem of this background knowledge, because we need to, a robot at least in such a situation, it should ask what is the problem, and if it gets the answer, it should be able to understand it and somehow react to it. And collecting this common sense knowledge, which all the people have because they learn through all their life, gathering this knowledge to robot is a huge problem, and nobody knows how to do this. Because now algorithms are good in very narrow domains. So, for example, we are able to create algorithms to recognize emotions, to play chess, to play Go, to drive a car. But so far, we are better than robots. We have universal knowledge. So in a single domain, a robot or algorithm could be better than us, but when we take into account all the possibilities that average human being have, there is a huge gap between algorithms and human, fortunately.
To abuse my position, that's to just to pump up the time, but thanks for the extremely useful inspiration for me, because in the previous panel I mentioned that I'm working right now on some to the complexity, information over abundance and ignorance. Ignorance is now my main topic relating to social phenomena. So let me just, I will ask you some questions, but I would like to share with you some reflections with you and with the audience. First of all, I find this panel as absolutely fascinating. I truly regret that we are a good audience. Anyway, I think it will be then available on YouTube or on different websites. My first point is that when studying the problems that you've presented, we have at least 5 layers, 5 levels. The first one is the philosophical one. It's cheap. Usually at this stage, people talk about consequences of artificial intelligence. I recall Stanislav Lem and Isaac Asimov. And they wrote about this some 70, 60 years ago. So then, because there are plenty of specialists of AI of that kind. With philosophical, very philosophical comment, I'm not going to go deeply to this. My very wise colleague, the physicist and very skilled, when we talked a few weeks privately, he told me in the kind of discussion that it will take us 100 years as to understand how the brain is working. I don't know. I just something like that, the brain is so complex. Then we have the second level, functional general. I'm studying economic, social, and so on. I feel slightly stronger at that level. Then functional specific, for instance, how the neural networks are working and so on and so forth. I'm trying always to put things in order, because usually I'm quite chaotic. So that's why I'm putting things in order. The next level of discussing AI is those software. And the last level is software development. So I have this whole 5 levels, so we put it in a more systematic way. So then you can discuss it as kind of my simple systematization. So there's and then my questions, and not questions, but just in speaker, it will take us hours or days to respond to this. My main problem is, several problems that I can, what are the barriers in models of cognition or in AI, whatever we may call it, 2 types of AI and so on. Functional aspects, how to model the functions, then the depth of reflexivity. In my research right now, it's a kind of patent. I'm not going to, because it's a kind of work in progress. We are now rediscovering the infinite regress. To what level we have to have reflection about reflection, and so it's an old philosophical problem. And at present, we are now facing the same problem. For instance, deep fakes. Reflection. Somebody's saying this is fake, but somebody saying that this is fake may be saying that this is fake, that this is fake. Then we have to trust them and so on. This problem of the propaganda, it's fascinating problem at present. For instance, it's an object of my interest. So it's a problem of reflexivity. Then what is the barrier? Whether it's a barrier with hardware, computation. Now, you've mentioned something fascinating, the barriers of energy, or Bitcoin. That we will be not able to process such a large amount of data because of the energy barriers and money and energy. So it's quite interesting. And then are there any problems with software? at the mathematical levels to develop software for AI, you know, because it's not like a linear algorithm, do this for from n of 1 and to n. I remember the old patterns of developing software. So these are those points here. And now some additional comments to this. And this is, of course, they are very practical. We'll end up with the joke. I'm warning my younger colleagues in business management that their life in 10 years or in 20 years from now will be very difficult, because we will observe the end of classical science, especially in social sciences. It will be the computer, because right now it's easy, it's just a matter of years. Then the computers will write text in social sciences. You provide the text, you provide the data, they will search it, and so on and so forth. Publicly, at the meeting of the American Academy of Management, I raised that question to one of the leading scholars, and his response was very funny. First of all, he said, I'm much wiser than all the computers. Very jealous, very, let's say, spitty person. Let's say very, very smart. But the second was that computers wouldn't be creative. My relatively sharp answer was, how many creative works in social sciences could you find? You know, so that's another story. And I will finish with two jokes as to. Once I gave during the classes with the first-year students of business management, general management, I asked them to be creative, how new education will be looking like, the robots and so on, and there's all that. And their main problem was how to find jobs for the unneeded professors, you know. So that I wanted to revenge on them because they were smart, and their robots were still linear, extrapolated with the machines, you know, not just human bodies. And I recall the stories of the 19th century who wrote how the year 2000 would be looking like that, the flying ships, you know, with steam engines. I've told you are still thinking linear. It was my revenge on them that they wanted us to be fired. But this is a very important practical problem. I wish a good retirement, or we will have to learn, you know, the younger scholars. And then the joke. The joke is quite what we observe right now, and they said that we observe the emergence of the jobs who will be not endangered by computers, by artificial intelligence. For instance, horse riders. The students told me such examples. And one of those jobs is the feminine hairdresser. Because, you know, with the man, I can go to the robot, please, shortcut, and then I have the short. And with the ladies, so hairdressing is quite complex. Well, I told it to a young lady who during the hairdressing, and she said, you know, because there are so many combinations of female and feminine hairdressing that any computer will be able to cope with that. You know, so even the most sophisticated machine learning and so. But I would like to refer. So this is a new phenomenon. When I tell it to the students, that I'm afraid that they will have no students during the next lecture, because they will go to the hairdressing, horse riding, or floristic decoration. But just I'm not going to extend the time, but what are your reflections on those, not on at the level for this, but what are your reflections, especially in that field, that concerning the barriers of, let's say, of development of artificial intelligence imitating human cognition, or maybe my colleague was not right that it will take us 100 years to understand brain, maybe shorter. But so I repeat them, the functional aspects of whether we will be able to, because cognition of emotion is still behavioral. It's external. We don't, of course, we can add, let's say, neuromarketing to this. So there's a functional levels, and that what is fascinating me, that the level of self-reflexivity of the computers, of those machines, then the hardware, including energy, and the problems of mathematical sophistication or cognitive sophistication of software for cognitive systems. Of course, we could talk for hours, but just a brief reflection. Thank you.
Okay, so I will say to this first barriers, problems. So mostly the barrier is when we think about computer science, robot, artificial intelligence. This is always quantitative. So we have we gather data, and based on the data, we want to have some patterns. But when we consider such a problem in some philosophical, sociological, psychological way, is often qualitative. And qualitative is hard to translate into numbers. For example, so when I talk about this emotion, this is everything is quantitative. So we can gather the information about the changes of the muscles, the changing of the heart rate, and so on. And based on this, we can give some conclusion that this is that emotion or that emotion. But in our communication, sometimes this mathematics, this data is not important, because more important is the empathetic way. It's not important that based on the data somebody is happy or sad. Most important is our empathy. If you are sad, that I can also feel sad, and I want to be with you, somehow say a good word, because I feel quite the same feelings that you can feel. And robot never, in my opinion, robots, computers, system never could feel this way. So the most important problem is between qualitative and quantitative. I think we can only simulate some states. We can, in the simulation way, reply on this states.
So maybe I will also add some of my thoughts. So the big barrier in developing AI is how to represent knowledge about the environment and how to process it. And these approaches that were used at the beginning when artificial intelligence was created used symbolic knowledge representation. So we were able to create, for example, sets of rules that could be used to infer what robots should do in a given situation. And it was working well, but only in simple environments. When such a robot could meet a lot of different objects, not only boxes, these objects could be placed in a chaotic way, not only in the table, then such simple approaches are not useful. So a lot of work was done to use neural networks to process these complex, for example, images or other signals. But we have lost this possibility to interpret what the knowledge was learned from the data. Because in the neural network, knowledge is hidden in the connections between artificial neurons, which is very difficult to analyze. So I think that now, according to this software, the barrier that should be that should give us other progress would be to combine somehow these new approaches, more using neural networks, with old approaches based on rules. Maybe now more common are ontologies, to create hybrid systems that could process complex data like images, but also could deal with knowledge, with symbolic knowledge representing our common sense knowledge. And then we could also add this self-reflection, because we could try to represent it using some ontologies, for example, or some algorithms. Adding this to the simple neural network is not possible, at least according to my knowledge. But when we have more complex hybrid systems, we could add it. And when we create such robots or AI, I think some jobs could disappear, but I think that in many areas they will be used as assistants. So they will probably not eliminate all radiologists, but maybe instead of 5 radiologists in the hospital, 1 or 2 will remain. And like you said, that the AI just help them to focus on some areas, and they will be controlling it. Similar problem was already observed in chess, because when in 1997 Deep Blue won with Kasparov, people could stop playing chess, because they could say that why to play it if AI is better. But they didn't. Chess player started to use AI to help them during trainings, and as far as I know, there was a huge progress in playing chess, because people are able to learn faster, learn better, and I hope that similar approach will be also in other areas.
Thank you, but if I may respond, of course, I'm not going to impose myself but that. First of all, only a brief comment referring to our previous session that you were absent, but knowledge has become the same term as agile. If somebody is a specialist in knowledge management, I was forced to study knowledge. I didn't treat many works on knowledge in management seriously. Knowledge, it's a very broad concept. Usually now I will ask somebody in knowledge management, could you define me knowledge? And for instance, I can reduce it to Russell's paradox, where the knowledge about knowledge management is a part of knowledge, so it's a classical Russell's paradox. So that is but thanks for this symbolic note. So truly, thanks for inspiration. It's very useful, and that it puts up our discussion knowledge about ignorance much higher, but that's my thing. And the second about a kind of hint about chess. Our supermaster of chess, Jan Krzysztof Duda, is a very close relative to one of our member of our faculty staff. Exactly, he is a son of her sister. And I'm sharing, all the reflections about the achievements of Jan Krzysztof Duda, and she told me how deeply chess has been changed since Deep Blue, it's becoming completely different. And what they could even study right now using those algorithms, emotional relation 2 days before the match, whether they had a family meeting or stress or joyful, relaxed. Of course, and using big data, another buzzword, big data in this. So collecting big data, they can even play chess better. Okay, so I'm not good. So that's all on my part. Any other questions or comments? Jakieś inne pytania?
The problem of emotion, which is very popular today, I think that we have very simple problem of classification and very complex and hard problem of choosing the right elements, right arguments. And I think that this is the problem generally, that we can teach computer only this what we know. So we are trying now, we are on the stage when we are trying to put our knowledge into computer, not knowing what knowledge is, yes, trying to put this schema of thinking in that system. The problem of data is, I think, that much more complex than the media talk about it. I recall one story about the system of recruitment in one of the top IT company, very often connected with artificial intelligence. They decided to create the recruitment system based on artificial intelligence for sustainability, for any kind of problem, social, just eliminate. So they create the perfect neural network, then they start with the problem of how to teach this network, what people we need to recruit. So the best source of this data are the CV of current workers, yes? So they teach the system based on the current workers. And what happens at the end? 2 weeks test show that all problems of sustainability were solved. The system recruit only white men, no other. Yes? So they say, okay, we must switch it off and return to the problem. Why? The data. And in every case, data in some kind represent, in that case, the knowledge. Yes? The knowledge of this organization. It is kind of representation. And we are trying to learn based on data. We're starting to create knowledge from data. Sometimes it can be similar, maybe like human, but we are do it unconscious, without the świadomość. Consciousness, yes? Without consciousness. The computer must do it for a given reason. And that thinks that this is the problem. We don't know how we learn, and we are trying to computer to learn. Thank you. Last.
Other questions or comments? Just a brief comment, because, oh, please.
Mm-hmm. Okay. So my comment would be that we need to remember about the background knowledge. So in some cases, it is enough to analyze the data, but in some areas, to give good answers, we need also background knowledge, like that color of the skin should have nothing to do with the employment. So
the problem was that this kind of data were erased from the input data. Use this kind of data
okay.
to teach the system.
Mm-hmm.
Yes? But he learned such a kind of behavior based on the cover.
So
there is some interconnection between
right with other.
When we do not know this interconnection, we cannot work intentionally.
So we need to be careful with such models.
Okay, I don't want to, once again, I'm not going to impose myself, but just two brief reflections. Professor Rudymek has mentioned a very important problem, because since we don't know how the brain is operating, so let's automatic translation. A few years ago, I would say to the students, look, learn the terminology of insurance or finance, it will make your life easier. A few years, I had a quarrel with one of my colleagues who was the owner of this language school. He said that never the computers would be able to translate directly, because it is, And that's quite interesting. At one point, another of my colleagues, from one of the, say, influential figures in systems thinking, Francis Heiligen, used the concept of global brain. He's from Brussels. Oh, retired from Brussels. And look what we have right now. That's as a kind of surrogate of going deeper into the brain. In translation, we use the global knowledge, the global brain, for helping us. We don't understand how we translate, but then having such a powerful number crunching possibilities, we are able to replace our brain by that specific function of a human brain, of the global brain, you know. So, okay. You want to share some reflections or?
Maybe the problem that could arise would be similar, that we need to be very careful because I'm not sure if we could trust to the answers given by many people from the internet. Like maybe you remember, there was some bot developed by Microsoft, I think, that was somehow installed on their web page, and people could talk with them, and it was learning from these dialogues, and very quickly it was removed from the web page because people thought it to become racist, Nazist, etc. So it could be dangerous.
Are there any questions or comments? If not, professors, and if your future professor, it's clearly visible. Thank you for your contribution. Really, it was very insightful. I think that I expressed the gratitude of the audience. Don't worry, it will be published, you know, so maybe the proof that we'll have a bigger audience, and thank you for inspiration, and I wish you successes in the future. We said that, let's stay in touch. So congratulations, Professor. Thank you very much.
Thank
okay.
you very much for the invitation.
Thank you much. Thank you much, Professor. Thanks very much. Okay, so now I think that we have 55 minutes longer break for lunch. Okay, thank you. Dzięki, mamy dłuższą przerwę na obiad. Dziękuję. Jest nas tutaj troszkę mniej, ale zawsze tutaj temat jest interesujący, więc sądzę, że będzie ciekawa dyskusja, prezentacja oczekujemy. Otóż, proszę Państwa, pan profesor Marcin Kędzior, reprezentujący nasz Uniwersytet Ekonomiczny, przedstawi pracę pod łącznym tytułem, prawda, tutaj mamy już, to jest tutaj mamy właśnie, i tu mamy właśnie Corporate Finance, Complexity versus Innovation, a konkretnie uwarunkowania finansowania jednostek gospodarczych. Widzimy na slajdzie tytuł. W takim razie, panie profesorze, proszę bardzo, nie mamy limitów czasowych, ale też mamy czas do godziny 16:15. Nie będziemy tutaj aż tak głęboko sięgać, także ile pan profesor uważa, że jest potrzebne. Proszę bardzo, potem będzie krótka dyskusja. Prezentacja jest po angielsku, więc to panu po prostu, it will be easier for you to read because the presentation is in English. Okay. Proszę bardzo, panie profesorze.
Dziękuję bardzo. Dzień dobry, witam państwa bardzo serdecznie. Dziękuję panie profesorze za możliwość przedstawienia naszych najważniejszych wyników. Dziękuję również panie profesorze za możliwość uczestniczenia w grancie, który tu też był dla nas taką troszkę i inspiracją i też taką dodatkową motywacją do właśnie podjęcia jakichś takich dodatkowych właśnie badań naukowych, także bardzo serdecznie dziękuję. Szanowni Państwo, to jest, mogę powiedzieć, część też naszego wystąpienia takiego dosyć na świeżo ze Stanów Zjednoczonych, gdzie akurat mieliśmy możliwość na Uniwersytecie Grand Valley State University właśnie zaprezentować część właśnie naszych wyników badań. I w pierwszej części chcielibyśmy się skupić na oddziaływaniu takiego zjawiska, które Państwo znacie tutaj na pewno bardzo dobrze, czyli praktyki związane z CSR na poziom zadłużenia polskich spółek, które należą jeszcze dodatkowo do sektora high-tech. Nasze motywacje były tutaj takie pewnie jak zwykle, czyli luka badawcza, czyli właśnie próbowaliśmy się znaleźć tutaj w najlepszy możliwy sposób. Nie wiemy, czy nam się tutaj właśnie udało, tak właśnie przynajmniej w ograniczonym zakresie właśnie światowej literaturze. Z parę słów takiego ogólnego wprowadzenia, generalnie spółki CSR, czy też powiedzmy spółki, które też właśnie szerzej należą do właśnie sektora wysokich technologii, są to takie spółki, które mają problemy z finansowaniem zewnętrznym i to dotyczy zarówno właśnie wyższego poziomu zadłużenia, jak i emisji akcji na giełdach papierów wartościowych. Tutaj dochodzi wysoka asymetria informacji do głosu, ale też ogólnie ryzyko, tak? Czyli bariery wejścia do tego sektora są na ogół nie takie bardzo duże, stąd też mogą pojawiać się potencjalni bardzo mocni gracze na rynku. Takie dodatkowe ujawnienia o charakterze niefinansowym, czyli oczywiście ujawnienia finansowe, ale również takie ujawnienia niefinansowe mogą mieć tutaj dosyć duży pozytywny wpływ na dostępność takiego finansowania. Dlaczego? Ponieważ asymetria informacyjna ulega zmniejszeniu wtedy i tutaj już pojawiały się takie badania, natomiast tutaj w oparciu o a to może tutaj za chwileczkę do tego przejdziemy. Też dlaczego spółki decydują się na CSR? Niektórzy mówią, że jest to moda, niektórzy mówią, że na tym również się zarabia pieniądze, ale w oparciu o różne badania międzynarodowe możemy zauważyć, że spółki, które stosują CSR, charakteryzują się wyższymi wynikami finansowymi, wyższą wyceną. No, może być to powiązane również właśnie z lepszym dostępem do kapitału. Ale też dlaczego jeszcze z innych powodów się właśnie decydują? Otóż chcą mieć dobre relacje z innymi interesariuszami, czyli to tutaj na pewno zmniejsza ryzyko różnorodnych konfliktów, powiedzmy na poziomie interesariusze, jednostka gospodarcza, ale też chcą faktycznie sprawdzić, czy te normy, standardy, które są stosowane w określonej spółce, one spełniają oczekiwania interesariuszy. Czyli może się okazać, że te oczekiwania są wyższe albo spółka jednak no nie do końca nadąża. Chyba w dzisiejszych czasach w wielu branżach spółka, która nie ujawnia takich dodatkowych informacji właśnie niefinansowych typu CSR, chyba ma trudniejszą sytuację, również konkurencyjną, nie tylko w zakresie zarządzania finansami w stosunku do innych podmiotów gospodarczych. I nasze motywacje były tutaj następujące. W oparciu o taką naszą najlepszą wiedzę oczywiście próbowaliśmy tutaj zrobić taką dosyć dokładną kwerendę literaturową, natomiast wiemy, że to jest zawsze ograniczone i oczywiście też nie zawsze mamy dostęp do jakichś lokalnych baz danych, ale tutaj korzystając z takich ogólnodostępnych baz danych, no nawet też takich powiedzmy właśnie wyszukiwarek typu nawet Google Scholar, tak doszliśmy do wniosku, że jest to jedna z takich pierwszych prac, która próbuje łączyć sektor high-tech, który no, jest takim troszkę nietypowym sektorem, jeśli chodzi o zarządzanie finansami. No i zarządzanie finansami w tym sektorze jest na pewno dużo bardziej skomplikowane niż w innych branżach. Praca, która by łączyła jeszcze CSR i dostępność kapitału. I to tak właśnie próbowaliśmy się tutaj właśnie skonfrontować w literaturze, czy tutaj coś takiego mamy. Na pewno to nie były badania, które były realizowane w Polsce, więc to tutaj może być jakiś taki, być może jakiś taki bardzo delikatny efekt nowości. Jeśli chodzi o polską specyfikę, możemy powiedzieć, że polskie spółki, które należą do sektora high-tech, mają troszkę trudniej, mają trochę pod górę, ponieważ jeśli chodzi o nakłady na badania, research and development w Polsce jako procent PKB to jest bardzo mało. Tak? Gdybyśmy powiedzmy my na poziomie Unii Europejskiej, to jest jeden z najniższych wskaźników. Jest to nieco ponad 1%. Możecie Państwo zobaczyć, że w Korei Południowej czy w Izraelu jest to 5% PKB. Tak? Więc też nie może nas dziwić, że stamtąd pochodzi dużo takich właśnie bardzo nowoczesnych startupów, które no bardzo mocno się rozwijają, ale też takie dojrzałe firmy, które oczywiście wszyscy tutaj bardzo dobrze znamy. Polski sektor high-tech jest dosyć takim zróżnicowanym sektorem, moglibyśmy powiedzieć, czyli są takie dosyć duże spółki, też głównie producenci gier, jeśli tutaj dobrze pamiętam, to też oni tutaj byli właśnie brani pod uwagę, które są już być może dosyć dobrze rozwinięte jak na rynek lokalny, ale nie są to oczywiście potężne firmy, jeśli mówimy o takim rynku globalnym. Natomiast są to firmy, które no, nie mają jeszcze takiej bardzo mocnej pozycji rynkowej. Koszty research and development dla nich są bardzo wysokie. Publiczne jakieś takie dotacje, no tutaj jakieś subsydia są możliwe, ale tutaj środki, tak jak właśnie wspominaliśmy, są ograniczone. Ale jest to sektor, gdzie pracuje dosyć dużo młodych ludzi. On jest bardzo otwarty, co ze zrozumiałych względów tutaj na nowe technologie, ale też na transparentność, na takie kwestie związane z etyką. Generalnie jest to sektor i musi być to sektor otwarty na zmiany, czyli tutaj też taka zmiana w zakresie stosowania takich właśnie strategii bardzo takich powiedzmy mocno powiązanych z CSR-em, to w tych firmach nie powinien być problem. Znaczy oni nie powinni bać się wdrażania, prawda, czegokolwiek, więc być może jest to dobry tutaj sektor w tym sensie, gdybyśmy go chcieli właśnie poddać jakiejś takiej właśnie głębszej analizie. Wprowadziliśmy 3 podstawowe zmienne zależne, czyli wyróżniliśmy, postanowiliśmy podzielić CSR na CSR pracowniczy, CSR społeczny i CSR środowiskowy. No i właśnie próbowaliśmy właśnie zobaczyć, czy tutaj poszczególne sfery CSR będą oddziaływały na dostępność finansowania. Tutaj głównie mówimy o finansowaniu dłużnym. Stosowaliśmy taką właśnie stopniową właśnie skalę Likkerta od 1 do 4, czyli 1 to jest najmniej ujawnień w zakresie CSR, 4 najwięcej. To jest taka metodologia, która była również w innych pracach brana pod uwagę. Wyróżniliśmy 3 podstawowe hipotezy. Pierwsza hipoteza, że tutaj ona głosi, że no będzie pozytywny wpływ tej właśnie domeny CSR pracowniczy, CSR społeczny, to jest druga hipoteza, i CSR środowiskowy na poziom zadłużenia, czy też na właśnie możliwość właśnie pozyskania dodatkowego zadłużenia. Jeszcze o próbie badawczej. CSR to są takie ujawnienia dodatkowe niefinansowe, czyli to są takie ujawnienia, które zaczynają być coraz bardziej obligatoryjne i są już one w coraz większym stopniu obligatoryjne. CSR to jest część tych ujawnień niefinansowych, ale można powiedzieć, że Polska Giełda Papierów Wartościowych to jest taki rodzynek może troszkę w tej części Europy, ponieważ awansowaliśmy już do rynków rozwiniętych, a co za tym idzie, jakość właśnie sprawozdawczości spółek i finansowej, i niefinansowej, czyli również prawdopodobnie CSR, jest dosyć wysoka. Czyli też można tutaj zakładać, że te ujawnienia właśnie w zakresie CSR na polskiej giełdzie papierów wartościowych powinny być relatywnie dobre, albo być może powinno być ich więcej w stosunku do innych giełd, które powiedzmy operują w Europie Centralnej i w Europie Wschodniej. Nasza populacja liczy 34 spółki, jest to populacja tutaj właśnie zawężona przez bazę danych. Tutaj badaliśmy następujące lata, 2016-2021 i w sumie 92 obserwacje. Też tutaj dostępność danych jest bardzo wysoka i również jakość tych danych jest dosyć wysoka, ponieważ wiele danych ściągaliśmy ręcznie i jeszcze sprawdzaliśmy, niejako właśnie weryfikowaliśmy funkcjonowanie bazy danych, ale oczywiście dane związane z CSR były ściągane tylko i wyłącznie ręcznie, prawda? Czyli najpierw opracowaliśmy metodologię ściągania tych danych i oceny i dopiero później właśnie przechodziliśmy do oceny właśnie ujawnień w zakresie CSR. Jak ocenialiśmy ujawnienia w zakresie CSR, 1 punkt, jeśli nie było w ogóle ujawnień, 2 punkty, jeśli była to tylko taka ogólna informacja, 3 punkty, jeśli to tutaj było trochę więcej informacji, no i 4 punkty, gdy to już była jakaś większa strategia albo już faktycznie dane liczbowe, prawda, jakie tutaj kwoty były właśnie przekazywane na różne cele, takie powiedzmy wrażliwe społecznie, więc wtedy można było uzyskać 4 punkty. Bardzo podobna metodologia również była stosowana w literaturze przedmiotu. Przeprowadziliśmy tutaj różne właśnie jeszcze testy, takie troszkę właśnie weryfikujące uzyskane wyniki. Otrzymaliśmy ostatecznie model, który ma tutaj taką siłę opisową na poziomie 0,48. Biorąc pod uwagę liczbę zjawisk, które wpływają na zadłużenie w przedsiębiorstwie, udokumentowanych czynników w literaturze światowej jest ponad 100, czyli dla tych naszych tutaj kilku myślę właśnie zmiennych ta powiedzmy siła modelu jest pewnie akceptowalna. Jakie wzięliśmy pod uwagę zmienne? Wzięliśmy pod uwagę zmienne kontrolne, co jest tutaj wielkość firmy, wiek to taka powiedzielibyśmy trochę zmienna kontrolna, taka tutaj trochę zmienna, którą warto może tutaj analizować też w tym kontekście, ponieważ są to relatywnie spółki młode i tutaj każdy rok funkcjonowania na rynku dłużej to jest no może nie jakaś gwarancja, ale jakiś tutaj przyczynek do tego, żeby te firmy po prostu przetrwały. Możliwości rozwojowe, płynność, no, możliwości rozwojowe, no to też taka bardzo dobra zmienna do tej branży, prawda, ponieważ akurat te branże charakteryzują się takim przynajmniej potencjałem takiego dużego rozwoju, no i też takie właśnie zmienne typowe dla tej branży, czyli aktywa niematerialne, prawda, czyli różne licencje, patenty, koncesje, oprogramowanie komputerowe i nakłady na badania i rozwój. My to jeszcze troszkę inaczej ujęliśmy od strony księgowej, czyli podzieliliśmy te właśnie badania na badania własne i tak jakby badania zakupione. I to od strony księgowej się to troszkę inaczej wykazuje, ponieważ te zakupione można powiedzieć, że jest łatwiej wykazać jako aktywa, co ma wpływ też na wynik finansowy i na sytuację finansową. Te we własnym zakresie trzeba udowodnić ich powiedzmy użyteczność rynkową i taki sukces rynkowy, co już jest dużo trudniejsze i też mogę powiedzieć, że od strony księgowej takie badania się rozlicza w czasie. Więc ujęcie tego statystyczne nie jest łatwe, ponieważ czasami ujawniamy tylko część tych badań. Na przykład w następnym roku powiedzmy następną część, a część musimy wpisać tylko i wyłącznie w straty. Czyli tutaj nie powstają z tego właśnie żadne aktywa. Wyniki, regresja, wyniki regresji. Uzyskaliśmy potwierdzenie dla CSR pracowniczego, czyli tak naprawdę, no może tutaj potrzeba oczywiście przeprowadzić jeszcze inne badania, chociaż jest to prawdopodobnie taki użyteczny wynik dla tych spółek, ponieważ te spółki no, nie zanieczyszczają środowiska bardzo mocno, więc one prawdopodobnie nie muszą tutaj ujawniać dodatkowych danych takich właśnie środowiskowych. No, istnieje taka swoista konkurencja o pracowników i też pewnie ten CSR taki właśnie socjalny może nie jest najważniejszy, ale pracownicy są najważniejsi, prawda? Czyli jeśli w firmie informatycznej nie mamy pracowników, nie mamy programistów, to są największe aktywa tego typu firmy, więc no, tutaj wykazaliśmy, że niejako ryzyko utraty pracowników ma wpływ na zadłużenie, tak? Czyli jeśli to ryzyko jest niskie, to zadłużenie tutaj będzie prawdopodobnie większe. Z innych jeszcze ciekawych wyników uzyskaliśmy ujemny wpływ wielkości, czyli tak naprawdę lepiej radzą sobie spółki mniejsze niż większe, to jest tutaj ciekawe. Spółki starsze w większym stopniu tutaj mają szansę pozyskania kapitału obcego, w tym zadłużenia. I też co ciekawe, firmy mniej płynne zadłużają się, ale to może wynikać z tego, że firmy, które mają mniej własnych środków, niejako potrzebują finansowania zewnętrzne. Dlatego są one być może mimo gorszego standingu finansowego, no niejako zmuszone do zadłużania się. Firmy, które wykazują więcej aktywów niematerialnych i intensyfikują prace związane z właśnie badaniami i rozwojem, w większym stopniu uzyskują finansowanie. Z jednej strony dla takich pozycji mamy wyższe koszty agencji, większą potrzebę kontroli, ponieważ są to cały czas zjawiska niematerialne i one są bardziej ryzykowne, no ale z drugiej strony są to kluczowe aktywa w tej branży, czyli jeśli określona firma rozwija tego typu aktywa, no to możemy powiedzieć, że że niejako poprawia swoją pozycję konkurencyjną. Czyli tutaj przynajmniej operacyjnie można na pewno powiedzieć, że jest to zjawisko tutaj do pewnego stopnia oczekiwane. I podsumowanie tutaj tej części, no uzyskaliśmy tylko potwierdzenie CSR pracowniczego, ale to być może to wynika z tego, że to są jednak kluczowi interesariusze, jeśli chodzi o spółki high-tech, czyli tacy właśnie utalentowani programiści, właśnie badacze, właśnie działy właśnie badawczo-rozwojowe są oczywiście najbardziej istotne. Zmniejsza to ryzyko przynajmniej konfliktów tutaj na linii pracownicy przedsiębiorstwo, zmniejsza ryzyko bankructwa naszym zdaniem i zmniejsza koszty kapitału obcego, czyli niejako ułatwia pozyskanie tego kapitału, ponieważ jego koszt będzie, chyba nie to, ponieważ jego koszt będzie niższy. Czyli możemy powiedzieć, że CSR oddziałuje na poziom zadłużenia przedsiębiorstw, natomiast wybrane domeny, prawda? Nie wszystkie sfery, tylko te sfery, które są najważniejsze z punktu widzenia ryzyka przedsiębiorstwa i tutaj taką sferą jest CSR pracowniczy, czy też ogólnie pracownicy, prawda, w spółkach high-tech jako najważniejsze aktywo. Nasze badania mają tutaj oczywiście pewne swoje ograniczenia, czyli nie jest to jakaś na pewno duża populacja badawcza, no ale wzięliśmy wszystkie spółki, które właśnie należały do tego sektora, które emitują papiery wartościowe na giełdzie w Warszawie. No myślimy, że też tutaj można byłoby jeszcze inaczej właśnie dobrać zmienne, być może jeszcze bardziej specyficzne zmienne, które są charakterystyczne dla sektora high-tech. Więc to są tutaj nasze jakieś takie uwarunkowania i jakieś ograniczenia naszych badań. No i prawdopodobnie no, można byłoby teraz jeszcze popatrzeć, czy w okresie, chociaż myśmy już tutaj rozpoczęli okres pandemii, z tego co sobie dobrze przypominam, tak, 2021, no więc można byłoby zobaczyć, jak to wygląda teraz, prawda, czy właśnie mamy tutaj do czynienia z jakimiś zmianami, czy nie. Także bardzo serdecznie dziękuję za uwagę, za tą część. Mam jeszcze drugą część właśnie prezentacji, także właśnie nie wiem, czy to można od razu, także właśnie bardzo dziękuję. A to już coś innego. Jakbyśmy mogli włączyć drugą właśnie prezentację, także bardzo proszę. Tak jest, dziękuję bardzo. Proszę Państwa, druga część mojego wystąpienia dotyczy również finansowania przedsiębiorstw. My tutaj zajęliśmy się akurat sektorem energetycznym, który też jest takim bardzo nietypowym sektorem, a może też takim dosyć, powiedzielibyśmy, specyficznym ze względu na to, co się dzieje ogólnie i w gospodarce, i ze względu na fakt, że ochrona środowiska to już nie jest tylko hasło, tylko faktycznie przedsiębiorstwa zaczęły tego typu właśnie programy wdrażać i one no, okazuje się, że są coraz właśnie ważniejsze dla właśnie różnorodnych interesariuszy, czy wręcz dla klientów. Jak są już ważne dla klientów, to już to zaczyna być to tak naprawdę bardzo ważne. Dlaczego, proszę Państwa, sektor energetyczny możemy powiedzieć, że dostęp do finansowania zewnętrznego, w szczególności zobowiązań długoterminowych o charakterze inwestycyjnym, dla tego sektora zaczyna być w coraz większym stopniu ograniczony. Znamy przykłady dużych banków europejskich czy też banków polskich, które przestają albo przynajmniej deklarują na razie, może to jest jeszcze element deklaracji, finansowanie tak zwanej black energii, czy też powiemy brudnej energii. Mamy też tutaj pewne wytyczne i właśnie z Komisji Europejskiej jakieś takie może nie zalecenia obowiązujące, natomiast jakieś takie właśnie wytyczne w zakresie finansowania spółek, które właśnie wytwarzają tego typu właśnie brudną energię. W Polsce jeszcze ten problem wydaje nam się mocno zdynamizowany, ponieważ jednak polska energetyka w dużym stopniu jest oparta na węglu. Więc to jest takie dodatkowe zjawisko, które może bardzo utrudniać finansowanie tego typu podmiotów teraz, ale i w przyszłości. Ale też polska energetyka jest przed transformacją i energetyczną, ale też byśmy powiedzieli technologiczną. Nawet gdy tutaj mówimy o produkcji energii elektrycznej opartej na węglu, to tak naprawdę takich nowoczesnych instalacji i elektrowni tego typu mamy bardzo mało. Także to są cały czas producenci, którzy procesy modernizacyjne zostawili trochę z tyłu i to prawdopodobnie tutaj będzie rzutowało i na ich wyniki, i na dostępność finansowania. Tak, czyli właśnie tutaj z tego właśnie powodu wydaje nam się, że tutaj właśnie warto podjąć tego typu badania. My postawiliśmy jeszcze tutaj właśnie problem troszkę inaczej, ponieważ już CSR-em zajmowaliśmy się w poprzedniej pracy. Tutaj chcielibyśmy popatrzeć na corporate governance, czy on funkcjonuje tutaj właściwie i czy ten nadzór, oczywiście właścicielski, ale już też taki szerszy nadzór przyczynia się do powstania takich trochę lepszych praktyk właśnie w tego typu jednostkach gospodarczych. Przede wszystkim literatura bardzo mocno akcentuje, że dobry system corporate governance powinien ułatwić dostęp do finansowania, czyli koszty agencji powinny być niższe. Koszty asymetria informacyjna również powinna być niższa. Konflikty tutaj między poszczególnymi interesariuszami, czyli właśnie na linii klienci, powiedzmy organizacje tutaj, które zajmują się ekologią, czy też organizacje, czy jakieś tutaj instytucje nadzorujące, powinny bardziej przychylnie patrzeć tutaj na takie podmioty, które no być może właśnie tutaj angażują się również w CSR, natomiast jeśli tutaj nadzór też nad tymi podmiotami będzie może bardziej taki efektywny. Istnieje bardzo dużo teorii struktury kapitału. Ja tutaj może nie będę bardzo mocno tych teorii przypominał. One są i częściowo warunkowe i możemy powiedzieć, że tutaj te teorie są to też takie i teorie ogólnofinansowe, jeśli mówimy o finansach przedsiębiorstw, czyli one się tyczą nie tylko struktury kapitału, ale i no tak naprawdę praktycznie wszystkich zjawisk na poziomie zarządzania finansami. Te teorie też troszkę moglibyśmy zmodyfikować dla spółek energetycznych. Znaczy, można powiedzieć tak, że prawdopodobnie w krótkim okresie czasu firmy będą korzystały z tak zwanej kolejności źródeł finansowania. To tutaj z języka angielskiego nazywa się kolejność dziobania. Czyli prawdopodobnie najpierw będą korzystały z zysków zatrzymanych, a następnie później z kapitału zewnętrznego, który wiąże się z niejako z większym ujawnieniem kart, prawda? Czyli muszą ujawnić więcej informacji, czasami nie chcą tych informacji ujawniać, tak? Czyli jeśli przykładowo firma Toyota już dawno temu rozpoczęła pracę nad silnikami elektrycznymi czy hybrydowymi, nie chwalili się tym od razu, tak? Mieli własne finansowanie, one się zresztą finansują głównie właśnie w oparciu o zyski zatrzymane, więc nie musieli tego robić, nie musieli. Inne przedsiębiorstwa, jeśli by chciały zebrać kapitał na tego typu inwestycje, musiałyby takie informacje przekazać albo na giełdzie papierów wartościowych, albo konsorcjum banków, które finansuje na ogół duże projekty inwestycyjne, co już oczywiście wiązałoby się z wyciekiem informacji. Ale w długim okresie czasu większość spółek korzysta z teorii, która jest tutaj wiersz wyżej, czyli to jest teoria kompromisowa, która zakłada, że przedsiębiorstwa w długim okresie czasu będą dążyły do tak zwanej optymalnej struktury kapitału. Czyli takiej struktury, która jest dla nich najbardziej korzystna z punktu widzenia wyniku finansowego i wartości firmy. Czyli pewnie pecking order theory działa bardziej krótkoterminowo, trade-off theory będzie działała bardziej długoterminowo. My wprowadziliśmy tutaj naszą podstawową zmianę objaśnianą, to będzie poziom zadłużenia, czyli jest to wartość wszystkich zobowiązań do sumy aktywów czy pasywów, byśmy powiedzieli, za wyłączeniem jeszcze rezerw, które mają bardziej charakter księgowy, a nie są takim elementem takiego aktywnego zarządzania finansami. No i wprowadziliśmy tutaj 3 grupy zmiennych, które oddziaływują na poziom zadłużenia w tego typu spółkach. Jakość systemu corporate governance, charakterystyka prawda, osoby zarządzającej, która oczywiście też ma tutaj bardzo mocny wpływ na tak istotne decyzje jak sposoby finansowania i zmienne kontrolne, które pojawiały się jeszcze w innych pracach badawczych w ramach omawianej problematyki. Zmienne związane z corporate governance to między innymi wielkość Rady Nadzorczej, czy pojawia się tutaj własność instytucjonalna. Inwestorzy instytucjonalni zwracają bardzo mocno uwagę na ryzyko i na stopę zwrotu. To są dla nich takie 2 najważniejsze czynniki, czy od strony finansowej właśnie tutaj podjąć się pewnej inwestycji w określoną spółkę. Więc tutaj taki czynnik ryzyka jak zadłużenie będzie dla nich na pewno bardzo istotny, ale oni z drugiej strony bardzo dobrze zarządzają ryzykiem, więc można zakładać, że oni mogą tolerować wyższy poziom ryzyka, aby osiągnąć wyższą stopę zwrotu. Własność państwa. Tutaj mamy do czynienia w wielu spółkach energetycznych z taką dosyć dużą, właśnie istotną własnością. Możemy tutaj prawdopodobnie zakładać, że własność państwa może oddziaływać negatywnie ze względu na to, że menadżerowie spółek państwowych mają taką naturalną awersję do ryzyka. Tak? Czyli nawet jeśli to będzie powiedzmy kredyt udzielany również przez bank państwowy, to jednak wiąże się to tutaj z być może zagrożeniem takiego status quo. I jeszcze tutaj takie dodatkowe zmienne dotyczące prezesa zarządu, czyli jego doświadczenie w firmie. Z doświadczeniem jest tak, jeśli to doświadczenie jest większe, to też ten prezes jest niejako bardziej pewny siebie, bardziej zna firmę, bardziej zna ludzi. No, już ma też rozbudowaną sieć takich kontaktów wewnętrznych, tutaj oczywiście pozytywnie rozumianych. Być może w większym stopniu będzie się właśnie finansował wtedy poprzez zadłużenie. Wiek CEO to jest to taka zależność nieliniowa do końca, czyli jak jest młody CEO, to jest bardziej odważny, jak jest starszy CEO, podobno jest mniej odważny albo jest w większym stopniu świadomy zagrożeń. Edukacja CEO, no to tutaj mamy różne typy edukacji. Zakładamy, że ta ekonomiczna oznacza wiedzę, prawda, z ekonomii i z finansów i będzie wiązała się z wyższym poziomem zadłużenia. Jeszcze mamy zmienne kontrolne, rentowność może oddziaływać w różny sposób na zadłużenie przedsiębiorstw, ale na ogół pozytywnie, prawda, bo to jednak będzie ryzyko pod kontrolą, ale z drugiej strony pamiętajmy, że firmy bardzo rentowne mają dużo własnych niejako środków, więc być może tutaj nie do końca będą zainteresowane zadłużeniem i krótko i długoterminowym. Wielkość spółki to oczywiście również mniejsze ryzyko, jeśli spółka jest duża. Płynność, no to też oczywiście, jeśli jest płynność pod kontrolą, to jest łatwiej się zadłużyć. Asset turnover to jest Efektywność operacyjna, czyli jeśli ta efektywność operacyjna istnieje i do tego dodamy efektywność finansową, która jest wyrażona poprzez ROA, size i liquidity, no to powiemy, że wtedy takie najważniejsze czynniki ryzyka są pod kontrolą. Asset depreciation to są już takie bardziej księgowe uwarunkowania. Polityka amortyzacji, czyli powiedzielibyśmy może w ten sposób, jeśli prawo podatkowe jest takie bardzo fiskalne i przedsiębiorstwa muszą płacić dużo podatków, to zadłużają się po to, aby tych podatków płacić mniej. I tutaj odpisy amortyzacyjne są takim bardzo dobrym przykładem. Nawet mogę powiedzieć, że w mniejszych firmach, jeśli rozliczamy osoby, które prowadzą działalność gospodarczą, to oni tak naprawdę się bardzo denerwują, jeśli mają wysoki wynik finansowy, bo on od razu będzie podstawą opodatkowania. Więc oni tak naprawdę lubią zerowe wyniki finansowe. I ostatnia zmienna market to book ratio, czyli możliwości rozwojowe przedsiębiorstwa, tak? Czyli jaka jest wycena rynkowa do takiej czysto wyceny księgowej. Jeśli ta różnica jest duża, no to powiemy, że taki potencjał rozwoju takiego przedsiębiorstwa będzie bardzo wysoki. I wprowadziliśmy tutaj następujące hipotezy. Wyższy poziom z akcjonariatu instytucjonalnego pozytywnie oddziaływuje na strukturę kapitału. Obecność inwestorów, właśnie państwa, zmniejsza poziom finansowania długiem i wielkość Rady Nadzorczej negatywnie oddziaływuje na poziom zadłużenia. I tu jest nasz model. Też oczywiście czynników jest bardzo dużo. My tu już też nie prezentujemy wszystkich danych, ponieważ tu była jeszcze przeprowadzona wcześniej analiza korelacji, żeby uwzględnić jakieś zależności między właśnie zmiennymi niezależnymi, ale to jest tutaj nasz ostateczny model. Lata, za które był przeprowadzone 2012, badanie 2020, no ale też oczywiście myśmy to badanie przeprowadzili w roku 2021, ale jeszcze nie było oczywiście danych księgowych, czy też powiedzmy szerzej rozumianych za rok 2021, więc tutaj musielibyśmy czekać do roku 2022 i przynajmniej tutaj do lipca. Ale zbieraliśmy jeszcze dane przede wszystkim dotyczące corporate governance z raportów rocznych. I tutaj branża energetyczna na podstawie międzynarodowej klasyfikacji NACE i tutaj ta branża została tutaj wyszczególniona jako, tutaj chyba to jest chyba druga cyfra, jeśli dobrze pamiętam. Ostatecznie mamy 109 obserwacji tego typu spółek. Zmienne opisowe, to tutaj myślę, że możemy sobie podarować. Oczywiście wartości minimalne i maksymalne, no to one tutaj mogą być dosyć duże. I chcielibyśmy pokazać wyniki badań i okazuje się, że w sytuacji, jeśli przedsiębiorstwo posiada akcjonarat taki właśnie państwowy, państwo, to poziom zadłużenia w tego typu spółkach jest mniejszy, tak? Można byłoby zakładać, że państwo to jest tutaj gwarant stabilności, natomiast też tutaj mamy troszkę inne siły, które oddziaływują, czyli właśnie menadżerów, którzy raczej właśnie charakteryzują się taką niską tendencją do akceptacji ryzyka. Wielkość Rady Nadzorczej. Im większa Rada Nadzorcza, tym mniej zadłużenia w firmie. To tutaj może za chwileczkę będziemy to interpretowali. Edukacja ekonomiczna, jeśli dobrze widzę, tutaj została potwierdzona, czyli faktycznie CEO z takim doświadczeniem ekonomicznym w większym stopniu wybiera zadłużenie i być może też tego zadłużenia się nie boi. Płynność oddziałuje ujemnie, rentowność też oddziałuje ujemnie, ale to też może tutaj częściowo zgodnie z oczekiwaniami. No i przedsiębiorstwa z tej branży, które mają tendencję do tego, aby się rozwijać teraz i w przyszłości, potrzebują zewnętrzny kapitał, czyli też można zakładać, że takim właśnie typowym, bardzo dobrym zewnętrznym kapitałem, zwłaszcza w tego typu spółkach, które posiadają dużą wartość odtworzeniową aktywów, które można zastawić, czyli takie aktywa materialne, więc tym bardziej one tutaj będą miały potencjał większego zadłużenia. No i jeśli popatrzymy na nasze najważniejsze hipotezy, to faktycznie wyższy poziom takiego akcjonariatu instytucjonalnego nie został potwierdzony i nie oddziałuje na wyższy poziom zadłużenia. Natomiast potwierdziliśmy oddziaływanie ujemne państwa na poziom zadłużenia. Tutaj mówimy państwo jako inwestor i potwierdzenie, że większe rady nadzorcze powodują, że poziom zadłużenia będzie mniejszy. No i tutaj w dalszej części pracy spróbowaliśmy tutaj właśnie wybronić nasze wyniki. No może tutaj to nie jest najlepsze słowo, no w każdym razie tutaj część tych wyników została potwierdzona w oparciu o tutaj właśnie nasze oczekiwania, literaturę, czyli hipoteza 2 i hipoteza 3. Państwo jako inwestor faktycznie ogranicza ryzyko, ale nie jest tutaj skłonny do bardzo takiego szybkiego rozwoju przedsiębiorstwa i akceptacja ryzyka będzie mniejsza, czyli też mniejsze zapotrzebowanie na kapitał obcy. No i też tutaj jakieś takie dodatkowe może wytłumaczenie, że też tutaj menadżerowie, którzy właśnie zarządzają tego typu spółkami, nie patrzą tylko na sferę finansową, tylko i wyłącznie, ale również też na tą taką sferę powiedzmy właśnie społeczną, czy tu wręcz na jakieś takie właśnie agendy rządowe i ich właśnie oczekiwania. I większe rady nadzorcze na ogół negatywnie oddziałują na poziom finansowania. Na ogół są to rady, które mają dosyć taką wszechstronną gamę ekspertów, czyli i finansowych, i niefinansowych. Na ogół większe rady to jest wyższa jakość ekspertyzy. No być może też tutaj te rady doszły do wniosku, że jednak tańszy będzie kapitał akcyjny, tak? Jeśli w szczególności powiedzmy jakaś kolejna emisja akcji będzie pokryta przez państwo. Ale też tutaj być może właśnie boją się, tak jak tutaj właśnie wspominaliśmy, dodatkowego ryzyka. Edukacja prezesa zarządu, czyli jeśli ta właśnie edukacja jest ekonomiczna, jeśli on jest bardziej właśnie świadomy oddziaływania ekonomii, różnych aspektów finansowych, no to możemy powiedzieć, że prawdopodobnie w większym stopniu tego typu firmy się będą zadłużały i tutaj pozostałe czynniki, czyli płynność i rentowność oddziałują negatywnie. Czyli firmy, które mają wysoką płynność, niekoniecznie zgłaszają się po zadłużenie, ponieważ na ogół mają dużo środków własnych, czyli niejako nie potrzebują dodatkowych tutaj powiedzmy środków na rozwój. No i podobnie firmy rentowne, które są bardzo rentowne i akumulują dużo kapitału własnego, też nie potrzebują dodatkowych środków na rozwój. Dobrze. To tyle z mojej strony. Bardzo dziękuję za uwagę. Dziękuję bardzo.
Dziękuję bardzo panie profesorze. Proszę bardzo, tutaj mam teraz pytanie. Proszę tu się na siedząco spokojnie dyskutować. To teraz będziemy po polsku. Tutaj we're discussing Polish, but you can ask in English because the context was pretty clear, the context of that. Proszę państwa, czy mamy jakieś pytania, komentarze, any questions, comments to our speaker? Please, the floor is open. Proszę bardzo.
Mam pytanie dotyczące pierwszej z prezentacji. Na ile wyniki tych badań przeprowadzonych mogą być rozszerzone na inne sektory? Na ile są one specyficzne dla sektora wysokich technologii?
Dobrze, dziękuję bardzo za to pytanie. Wydaje mi się, że sektor wysokich technologii jest bardzo specyficzny i tutaj takie generalizowanie tych wyników na inne branże jest ograniczone. Może ono nie jest tutaj całkiem niemożliwe. Natomiast gdybyśmy mówili o wpływie CSR w branży energetycznej przykładowo, to na pewno CSR środowiskowy powinien być ważniejszy od CSR-u ludzkiego. Więc ja myślę, że w jakimś ograniczonym stopniu możemy powiedzieć, że CSR pozytywnie może oddziaływać na dostępność finansowania, być może również w innych branżach, ale inna sfera CSR-u może być ważniejsza.
Dziękuję. Chodziło mi przede wszystkim o to, że przecież można sobie wyobrazić, prawda, takie sektory, w których wpływ tego kapitału, prawda, ludzkiego jest zbliżony. Tak? No, pan profesor ruszył wątek energetyki chociażby. Też wydaje mi się, że jest to, ma bardzo zbliżone znaczenie.
To ja myślę, że chyba faktycznie w wielu branżach czynnik ludzki jest bardzo ważny. Myślę, że w branży energetycznej również. Są tutaj być może jakieś różnice między branżami. Znaczy wydaje mi się generalnie, że CSR to nie jest najważniejszy czynnik, który decyduje o dostępności finansowania. To na pewno tak nie jest. Jest to jakaś taka zmienna, która jest warta rozważenia, ale dla banku przy ocenie standingu kredytowego najważniejsze są na pewno takie zmienne jak płynność, rentowność i dotychczasowe zadłużenie. Tak? A to są takie dodatkowe zmienne, które nie wchodzą do takiego standingu kredytowego, ale takie jak na przykład jakość zarządu, czy tutaj otwartość na tego typu kwestie. To może być taki element taki dodatkowy, prawda? Czy właśnie czy to właśnie przeważy szale i właśnie ktoś otrzyma finansowanie, czy nie, ale to na pewno nie jest najważniejszy czynnik. Nie wiem, czy to wystarczy na to pytanie. Tak, dziękuję bardzo.
Proszę bardzo, czy ma jakiś pan profesor myśl?
W takim razie czeka nas taka rewolucja w zakresie postrzegania CSR, że może w przyszłości stać się takim kluczowym czynnikiem decydującym o finansowaniu, o przetrwaniu przedsiębiorstw.
Ja uważam, że tak, ale też mogę powiedzieć, że w wielu badaniach czynnik CSR nie okazał się istotny statystycznie. W badaniach, które łączą finanse przedsiębiorstw i właśnie CSR, ale też mogę podać taki przykład, bo dosyć dawno temu pracowałem właśnie w liniach lotniczych i pamiętam, jak były przygotowywane raporty roczne w takiej dużej niemieckiej linii lotniczej i pamiętam, że już naprawdę jeszcze przed moją tutaj pracą na uniwersytecie linie lotnicze bardzo zwracały uwagę na to, żeby samoloty nie emitowały zbyt dużo spalin, czyli żeby po prostu to były dosyć takie nowe, powiedzmy, dobre maszyny i żeby emisja hałasu też nie była zbyt duża. To tutaj mówimy o tych liniach lotniczych, to była polityka sprzed 20 lat i oni szacowali i nas tak właśnie informowali, że około 5% wtedy, a to już było dosyć dawno, 5% klientów, dla nich to jest ważne. Tak? Czyli wybór, cena, bardzo ważny czynnik, ale też tutaj dochodzą jakieś właśnie takie, powiedzmy, właśnie pozostałe czynniki. Ja myślę, że nie jest to 50% klientów teraz, ale może być to 10-15%. Czyli, ale to już jest też taka sfera, to już jest na tyle dużo klientów, którzy no, właściwie decydują o rentowności przedsiębiorstwa. Bo rentowność na poziomie 10-15% to jest taka rentowność, powiedzielibyśmy, bardzo dobra. Czyli jeśli ktoś zaniedba te 10-15% klientów, nie ma szans na dobrą rentowność. I gdybyśmy popatrzyli na firmy z listy Fortune, powiedzmy 500 albo 1000, tam praktycznie nie ma spółek, które nie są zaangażowane w CSR. I też na giełdzie firmy, które angażują się w tego typu praktyki, mają statystycznie wyższą ocenę, właśnie wyższą wycenę w stosunku do spółek, które no, nie angażują się w takie właśnie inicjatywy. Nie wiem, czy to tutaj wystarczy. Tak, dziękuję.
Jakieś inne pytania mamy? Any other questions or comments? Nie ma, ja mam jeszcze. Ja chcę tak przepraszam. Do you have any questions or comments? Sorry. For a moment, do you have any questions? I don't force you.
No problem.
That's good.
In beginning, you say about there are empirical research about corporate social responsibility and high sector. And this research mainly was done in developed and advanced country. And this is why you choose Poland, so interesting case. And did you make then a comparison what already was researched with your result? Is it the same trend or different? Thank you. Thank you.
Yes. So I think that there are some differences if we look at yes, Western Europe countries and Eastern Europe countries. Western Europe countries are more developed if you are talking about CSR. And this is, yes, really true. As I have mentioned, Lufthansa, so they had, yes, have had this, yes, policies for something like 20 years. So they are really advanced, but this is also question if we are talking about Anglo-Saxon corporate finance or continental corporate finance, because all these companies from Western Europe countries are more involved in that natural way in CSR, because all these social goals were for them more important than for, yes, let's say US. But we can find also that also, yes, US, yes, countries or, yes, from, yes, other Anglo-Saxon countries, we have also, yes, much higher involvement in CSR practices than 10 years ago or something like that. Okay, yes, this is fine? Okay, thank you.
Mamy jeszcze jakieś pytania, komentarze? If not, I will, nie wiem teraz czy po polsku, czy po angielsku. Okay, doesn't matter. Okay, good. So I will use English. Mike, I have two similar questions concerning both your presentations. The point is that I have a memory, not bad memories, but difficult memories from a PhD of one of our colleagues, Dr. Małgorzata Marchewka, when she proposed a very ambitious task to study the group dynamics of the upper echelon levels of management, the supervisory board and so on, and linking it with the overall effectiveness of the companies. It turned out it's quite difficult. It was a very interesting area of research. We've then investigated what the state of knowledge all over the world, and it turned out it's still too difficult to study. So this is my first lesson, just inspiration. And my second inspiration, my second question in this case concerns both, namely the choice of the hypothesis. The natural development in science is that theory or past experience, the results of past empirical data, is the background for formulating the hypothesis. I know what statistics is, and I have quite a malicious joke that any statistician and anybody using statistical methods have give me 6,000 numbers and I will tell you my story. You know, it's something malicious I can do. So my point is, in this case, especially in both cases, the corporate governance, the quality of corporate governance measured with qualifications, sometimes may have an astronomer, as you've mentioned, you know, so it could be somehow confusing. So basically, I have two questions. In your research, to what extent when creating the phenomenology of the problem, to what extent do you use existing theories, or you stick perfectly to a single one? I was one of the pioneers of introducing information asymmetry and agency problem in Poland, because it was a certain delay. So to what extent you've got a coherent inspiration from theory, then coherent inspiration from other empirical statistical research, and thirdly, is it truly just a kind of random, as a kind of not hypothesis, but conjecture? Let's assume, no matter what was in the past, what is in the past, what is in the present, so let's assume that I have the numbers, and let's seek for some regularities. So I think this is quite, it's somehow essential in studying complexity of finance. So, good.
So I think that it's a very difficult question. Yes, yes.
Don't give any complete answer. No. Just, it's necessary just when doing research on
Yeah. Yes, so I think that many theories or many variables are conditional. So sometimes we have many problems as corporate finance scientists that something is true for Western countries, and this is according to literature, but it's not still true for Eastern Europe countries. If we look at our hypothesis, if we are talking about the first article, because we couldn't find similar hypothesis for high-tech companies. So we have developed this hypothesis using some effects from high-tech companies, but also some results from different industries. Okay, so it was our proposal. But I am aware of the fact that we can predict probably different numbers and different correlations for different parts of the world and different set of data or different time period. So I would say that our main hypotheses are based on current literature, and control variables are based on these theories. So yes, this is like that.
Thank you. Dziękuję panu bardzo. Jakieś inne pytania, komentarze? Any questions or comments? If not, so let me just become official. Okay, let me become official. So dziękuję panu bardzo. Thank you very much and for a very insightful presentation. Don't worry that we are not so numerous because everything is recorded. Wszystko jest nagrywane i w związku z tym to będzie odpowiednio rozpropagowywane. Natomiast nie wiem, czy mam to oficjalnie zakończyć. Tak, no ale oficjalnie, więc powiem dziękuję oficjalnie. Dziękuję za udział. Thank you much for your participation. Zapraszam na jutro for other. I invite for tomorrow for other sessions. And once again, thanks to our boss, the head of the project, who is very, przełączam się, to bardzo pomógł nam pan. Proszę bardzo, okay, good. About what? So I think that's Professor Sołtysik. Yeah? Means, what is this project, socioeconomic?
Consequences, yeah. This is a project what?
It's a big, in Poland, the authorities want to stimulate the acceleration of growth of economic growth and competitiveness. So they give special grants for leading universities. That's the amount of money is relatively big when referred to the condition in Poland, and they want to stimulate those universities, not only our one, but also all the universities from the area, but not necessarily to accelerate the academic development to achieve higher levels in reference to the world standards. And it looks that our project was our part of the project was, we may say modestly, was relatively effective. May say the same about other parts of it, because as you can see the program, we have the program on NASN, so we can see that other parts of the project were relatively quite successful. So it's, and we are happy that it worked, that it worked. Unfortunately, this is still not holiday, but the students are not here and many colleagues are still on holiday, so they didn't come. And last but not least, the reason for less frequency is at the same time in London there is a funeral of Queen Elizabeth. So maybe some people wanted just to attend this, to observe this historic event. But so briefly saying this, the idea of the project is to stimulate, to accelerate the growth of Polish academic centers. Okay, thank you. W takim razie, proszę Państwa, jeszcze raz dziękuję bardzo tutaj naszemu szefowi. Dziękuję za dziś te wystąpienia w imieniu całego zespołu. To wszystko. Najważniejsza też była ta interdyscyplinarność, którą nam się udało zachować, że nawzajem się uczymy od siebie, prawda? To cóż, dziękuję Państwu bardzo. Thank you very much. And zapraszam na jutro.